Hi everyone, let's talk about what will be covered as part of this course. This course will cover the principles and deep dive into the concepts of Apache Kafka. What are the advantages of Kafka over the existing systems? This is purely a hands-on oriented course and you'll be doing a lot of coding throughout the course. First few tutorials of the course will show you how to download, install and run the Kafka broker and Zookeeper in your machine and publish and consume the messages using the console producer and consumer. Followed by that, there will be coding tutorials on how to implement the Kafka concepts and how to connect to Kafka using Java. Next section will cover the coding tutorials on how to implement the Kafka concepts and connect to Kafka using Apache Camel. Followed by that, there will be coding tutorials on how to implement the Kafka concepts in Spring Boot. Followed by that, there will be coding tutorials on how to Dockerize the Spring Boot app and run the Kafka broker and Zookeeper in Docker and connect the Dockerized app to talk to the Dockerized Kafka broker. By the end of this course, you'll have a complete understanding of Kafka and how to connect to Kafka and how to implement the Kafka concepts using different technologies. Here is how a typical organization architecture looks like. If you take a look at the architecture diagram, the top row specifies different departments and their applications in the organization. Each application generates a lot of data and all these data get stored in the data store. The center row specifies different types of data stores in the organization. And the bottom row specifies the analytics and user activity modules in an organization. There is a lot of data movement here and different apps talk to each other with the data. And here the architecture looks very complex and it is going to be more complex if the data grows over time. Eventually we are going to need more storage. Then we need to think about different backup strategies and etc. Each data store have their own data backup or data replication tools. But here I'm going to emphasize more on the messaging system, the reason being Apache Kafka is a distributed messaging system. Messaging is one of the popular trend in sharing the data between applications or systems real time. There are two popular legacy messaging solutions. One is Topic and Queue. And Topic implements the publish subscript semantics. In Topic, messages are published to the message broker and messages will be distributed to all of the consumers. Topic retains messages only as long as it takes to distribute them to the current subscribers. The subscriber must continue to be active for it to consume the messages. Let's discuss about queue. Messages are pushed to a queue and consumer will read from it. Limitation here is that you can have only one consumer per queue. In both the approaches, there is always a limit on the size of the messages because larger message may end up breaking the message broker or make the broker to perform slower. And legacy messaging solutions have zero fault tolerance. What do you mean by zero fault tolerance? I would like to explain the scenario using an example. Let's say we have a use case that reads the messages from the broker and processes the message and stores the attributes of the message in the DB. So here, consumer reads the message and processes the message. And after it is done processing, it is trying to persist the attributes of the message into the DB. But the DB is down, or there is a bug in the consumer code. Eventually, the data is not persisted into the DB. Under the scenario, there is no way the consumer can read this message again from the message broker. The reason being, the legacy message broker solutions kicks the message out of the broker as soon as the message is read by the consumers. That's not the case with Apache Kafka. The reason being, Kafka stores the message in the Kafka cluster and consumers can read the message again using different strategies. Let's see how the architecture looks like by the inclusion of Kafka. Here, with the inclusion of Kafka, the architecture looks very simple and throughout the organization we'll have the same interface to talk to each other. And here in the Kafka section, I have mentioned something called topic. We will discuss about what topic and what are the different features that are available in Kafka in the upcoming tutorials. What is Apache Kafka? Apache Kafka is a scalable, reliable, high volume and high throughput distributed messaging system. Apache Kafka is mainly used for sharing high volume data from one system to another system in real time and retention of data. LinkedIn started the development in 2009 and implemented in 2010 as their architecture solution. It was outsourced to Apache Software Foundation by 2011. Currently, this is one of the mostly used tools in Apache Software Foundation. Let's look at some of the advantages of Apache Kafka over the existing legacy messaging solutions. Messages are not removed from the topic as soon as the consumers consume it. Kafka is horizontally scalable. Kafka has strong ordering guarantees compared to a traditional messaging system. Kafka can handle high volume and it has high throughput. Kafka will perform the same whether you have 50 KB or 50 TB of persistent data on the server. And Kafka design supports loosely coupled producers and consumers. Kafka can also be used as a storage system. Kafka architecture. As we discussed in the previous tutorial, Kafka is a distributed messaging system. There are two main components which are required to feed and read messages from Kafka. The component that feeds a message are called producers. The component that consume the message are called consumers. You might be wondering where exactly the messages live in Kafka. The component that holds a message in Kafka are called topics. We need to create these topics in Kafka. Each topic will have a unique name to which the producers and consumers will push and read messages from it. We will discuss more about topic and its internals in the upcoming tutorials. Where does this topic live in the Apache Kafka ecosystem? These topics live inside a broker. A broker is nothing but a server which can hold n number of topics. We will discuss about the internals of brokers and how to create a topic in a broker in the upcoming tutorials. As I mentioned before, Kafka is a high throughput distributed message system. How Kafka achieves the distributed management? Kafka achieves it by introducing Kafka cluster, which is nothing but a group of Kafka brokers. The cluster will distribute the load coming into it and process the message simultaneously. Clusters can have a single broker or multiple brokers in the same or different machines. Before we step in further into Kafka architecture, I would like to give some knowledge about what is a distribution system and how it works. Systems or components in a distributed system are designed in such a way that it distributes the load within it and processes the load simultaneously. To achieve the simultaneous processing of the load, there needs to be a coordination mechanism, meaning each and every system in the cluster needs to talk to each other. In the world of distributed systems, these are achieved using a protocol called gossip protocol. There needs to be a system in place in order to monitor the health and metadata information about the brokers. That's when Zookeeper comes into picture. Let's talk about the role of Zookeeper. I would like to give an overview of Zookeeper. Zookeeper is a centralized service for maintaining configuration information naming, providing distributed synchronization, and providing group services. Zookeeper is responsible for maintaining cluster data, overall health of the Kafka cluster, and balancing the broker assignments and reassignments. These are the key roles which Zookeeper performs as part of Apache Kafka. So here I have mentioned broker assignments and reassignments. What does that exactly mean? For example, if any new broker gets added to the cluster, then how this broker can participate in taking up the load. If any existing broker in the cluster goes down, then the load should not be distributed to this particular broker. Zookeeper manages these kind of activities. With the addition of Zookeeper, let's take a look at the actual architecture of Apache Kafka. Zookeeper sits on top of all of the other components in the Apache Kafka for proper orchestration. With this, we came to the end of Kafka architecture. Here we are going to talk about how to download and install Apache Kafka. The prerequisites are given below. You should have a Windows or Linux or Mac OS installed in your machine. And you should have Java 8 installed in it. For this demo, I am using Mac. The process is the same for Windows or any other Linux platforms. Go to Apache Kafka downloads link and download the distribution. Okay, I'm going to go to the browser and then type Apache Kafka download. And this will take me to the downloads page of Apache Kafka. So you can download any of the distribution here. I'm going to download the Kafka 2.12 binary download. This will give you a tar archive file. For the purposes of saving time, I have downloaded the distribution already. I'm going to untar this archive file. It gave me a folder. Let's explore the contents inside the folder. In this tutorial, we will be focusing only on the bin and config folder. Let's explore what's inside the bin folder. There is a bunch of shell scripts and a Windows folder. Let's see what is available inside the Windows folder. I see a bunch of batch scripts. If you are using Windows platform, then you need to use the Windows folder to have the Kafka running in your machine. If you are using Mac or any other Linux platforms, then you must use the shell scripts in the bin folder. Let's explore what's inside the config folder. It has a lot of property files in it. We will be focusing only on the server and zookeeper.properties as part of this tutorial. Let's see what we have in zookeeper.properties. There are 3 attributes here, but the main focus is going to be on the client port attribute. I will explain you the importance of this attribute in a moment. Let's explore what we have in server.properties. This broker ID is a unique attribute which refers to the broker. If we have multiple brokers, then this number will be different for each brokers. And there are 2 other important attributes here. One is a zookeeper.connect and the other one is zookeeper.connect.timeout.ms. The port number matches with the one on zookeeper.properties. The Kafka broker connects the zookeeper using these attributes. The Kafka broker sends the metadata information about the broker and the topics in the broker using these attributes. With this, we came to the end of download and install of Apache Kafka. How to download Kafka using a command. Here I have the curl command and the URL. This is something which I copied from the Kafka website. This will give me the tar file, and I have a tar exe command appended to this. Basically that will untar the file and then just give the folder in your local machine. I'm using Mac for this demo, so I'm gonna run this command and then see what it gives me as an output. So I have this command stored in this GitHub repo. I'm just gonna copy it and then I'm gonna paste it here. As you see, it is downloading the content. To save some time, I have already downloaded this. I'll show you how the actual download will look like. So if you take a look at it, there is this Kafka 2.11-0.10.2.0. That's a folder that gets created when you run this curl command. And if you take a look at the contents, it will have the actual distribution that we downloaded in the previous tutorial. Let's have a hands-on exercise on how to start Zookeeper and Broker. I'm using Mac for this demo, and the software that I'm using is iTerm, which is similar to Terminal in Mac. If you are using Windows, you can either use command line or git bash for this exercise. Right now, I'm inside the bin folder of the Kafka distribution. If I do a ls, it will display the different scripts available in the bin folder. We need to have Zookeeper up and running before we start Kafka Broker. There is a Zookeeper server startup script file to start the Zookeeper. But you need to pass the Zookeeper configuration information as part of the startup script. The configuration information is available in the zookeeper.properties. I have created a GitHub repo for all the commands that I will be using as part of this tutorial. I will share this link towards the end of this tutorial. So here I have the Zookeeper command and I'm going to launch it. So now we have Zookeeper up and running. Let's bring the Kafka broker up and running. To do that, we need to make a small change before you actually launch the Kafka broker. We need to enable the property called advertised.listeners properties in server.properties file. So if you take a look at the server.properties, you have this attribute called advertised.listeners and the value will be your.localhost.name. This needs to be changed to localhost. If you don't make this change, what will happen is you will not be able to publish any messages to your topic inside the Kafka broker. Now we have made the change. Let's launch the Kafka broker. Kafka server.start.sh is a script file that will launch the Kafka broker. You need to pass the configuration information along with the launch script. The configuration is available in the server.properties, which is available in the config folder. So I'm going to copy the link from the GitHub link. So here, this is the launch command to start the Kafka broker. I'm passing the server.properties as an argument to this script. That's it. Now we have Kafka broker up and running. Kafka topic and partitions. As per the documentation from Kafka, the Kafka cluster stores streams of record in categories and those are called topics. A topic is a category or feed name to which records are published. We can compare this to a data stores in which the data is persisted. When topics are created in Kafka, it will be given a unique name. Producers produce a message to the topic and consumers read the message from the topic using the topic name. For each topic, Kafka maintains one or more physical log file based on the number of partitions in a topic. We will discuss more on the partitions in the upcoming tutorials. Let's discuss how the messages and where the messages are stored in topic. When a producer sends a record to the topic, the records are appended in an ordered immutable sequence of records. What do I mean by that? Is when a producer sends the message, each records appends next to each other. What do I mean by immutable? By mistake, the producer sends an incorrect message. In this scenario, there is no way for you to pull that message out of the topic and republish it. The only way to correct that message is by sending a new message as a follow-up message, and it is the responsibility of the consumer to ignore the incorrect message and process the correct message. In topics, messages are stored in partitions. A topic can have n number of partitions, and this will be defined during the topic creation. Each record in the topic will be assigned a sequential ID number called offset that uniquely identifies each record within the partition. Let's see what are all the attributes that are present in a record. A record will have a topic name, partition, offset value, and payload. Payload is nothing but the actual message content. From the consumer point of view, it is possible to have infinite number of consumers. Each and every consumers are autonomous to each other. For example, if one of the consumer goes down, it does not impact the other consumers. Let's discuss this with an example here. Here you have 2 producers and you have 8 consumers. Let's say two of the consumers goes down. In this case, it does not affect the other consumers, and the other consumers will continue to read the messages from the topic. How is this achieved in Kafka? This is achieved by offset value, which is available in the message. The offset is maintained by the consumers and it is independent of each other with the other consumers. When the consumers are created, you can either create the consumer to start reading the messages from the beginning or read it from the latest. I would like to explain this with an example. The offset value of consumer A here is 9 and the consumer B is 11. And as soon as the consumer reads a message and commits the offset, then it moves to the next value. Let's say I'm going to introduce another consumer and I would like to have this consumer read from the beginning. In this case, I'll pass an attribute while creating the consumer called read from beginning. And the offset will be set to 0 and it keeps increasing the offset until it reaches the maximum value. Whenever a new message comes in, then it will read the new message and increase the offset accordingly. The consumers can also reset to an older offset and reprocess the data from the past or skip ahead to the most recent record and start consuming from now. This is one of the terrific features of Kafka. I will show you a demo on this in the upcoming tutorials. Let's discuss the multiple partitions in a topic. In real world, most of the topics will have more than one partition. In this example, we have 3 partitions for a topic. The producer published the record into it. It is up to the system to decide which records needs to go into which partition. Each and every partition is independent of each other and maintains their own offset. What do I mean by that is the ordering is guaranteed only in the partition level. From the following diagram, the offset 0 in partition 0 is different from the offset 0 in the partition 1 and partition 2. So, which means each and every partition is unique and it is different from each other, even they are part of the same topic. Multiple partitions are the foundation for scaling, fault tolerance, and high levels of throughput. Let's discuss about the message retention in Kafka. The retention period of records in Kafka is configurable. The default retention period is 7 days. The retention period is specific to topic. So in the cluster, there will be n number of brokers and each broker will have n number of topics. In here, each topic can have their own retention period. This configurable retention attribute is available in the server.properties in the bin folder of the Kafka distribution. Let me show you where exactly it is located. So here you see this attribute. The attribute is called log.retention.hours. It is mentioned as 168 and this is equivalent to 7 days. So in here, let's say the retention period is 1 day. Then in this case, this record will be discarded after 1 day to free up some space in the cluster. Irrespective of all the consumers have consumed the message, the record will sit in the cluster until the retention period expires. The performance of Kafka is consistent with respect to data size, so holding the data for a long time is not an issue here. So since the data is going to stay until the retention period expires, there is a way, even if you have consumed the message incorrectly, you can come back and reread this message from the topic. This is one of the advantage of Kafka topic over the existing systems. How to create a topic, how to produce and consume messages in Kafka topic using console producer and console consumer. These console producer and console consumer are part of the Kafka distribution that we downloaded from one of the previous tutorial. I'm using Mac for this demo. If you are using Windows, then please use the scripts that are available in the Windows folder, which is in the bin folder of Kafka distribution. Now we have Zookeeper and Broker up and running. Let's create a topic. I have all these commands available in the Git repo. I'll be sharing you this at the end of the tutorial. Let me pull the create topic command. So here I have all the scripts for both Windows and Mac listed here. I'm going to copy the create topic command. So I'm going to clear it. So right now I need to navigate inside the bin folder of the Kafka distribution. So I have an alias set up here. So this alias take me to the bin folder of the Kafka distribution. Let me do a pwd, which tells me which directory I'm currently in. If you take a look at it, Kafka 2.12 0.10.2.0/bin. So this is a Kafka distribution that we downloaded, and I'm inside the bin folder now. We will be using the Kafka topics.sh script to create the topic. Let me do a ls. So in here, we'll be using this script. Similar to Windows, there is a batch file available for this. So I'm going to paste the copy that I copied from the GitHub repo. Sorry, I think it got overridden. So in here, we are using the create attribute to create the topic, and then so create attribute to create the topic, followed by the topic attribute, and followed by the topic name, and followed by the Zookeeper details. And here we have the replication factor and partitions. We will discuss about replication factor and partitions in a separate tutorial. In order to keep it simple, here I am defining only one partition. So let's create the topic. I'm going to run this command. So it says there is a topic which is already available, meaning I have run some sample programs before. Maybe the topic is still available. So I'm going to change the topic value to my first topic -1. So in here, this created me a topic. There is a describe command that is available to list the topics that are available in the Kafka broker. So I'm going to go to the GitHub repo, and then I'm going to copy this command. How to check the configuration of all the topics in the broker. It's available under that section. So in here, you see I'm using the same Kafka topics.sh script, but I'm passing an attribute called describe, and then followed by the Zookeeper values. So the topic that we created is my first topic 1, and I'm running this command. So there are plenty of topics in my local, but this is a topic that we created. If you take a look at the topic information, it has a partition of 0, partition count is 1, and replication factor is 1. These are the attributes that we passed when we created the topic. So in here, if we take a look at the partition value is 0 and replicas are 0, meaning in Kafka, all these attribute values starts with the index of 0. There is a leader and ISR attribute, which we will discuss separately in a different tutorial. Right now, we have the Kafka created. Let's instantiate the producer and let's publish some records into the topic. There is a ready-made script that is available to handle this scenario. Let me copy the console producer topic command. Here, the console producer basically is like a interface which will talk to the broker and which will let you publish the messages into the topic. The syntax is going to be Kafka console producer.shell script, and then you need to pass the Kafka broker information and then provide the topic name. Right now, this topic is actually ready to produce records to the Kafka broker. Now let's publish some messages. You just have to type some text and press enter. This will publish the message into the topic. So I'm going to type, hello, how are you? My first message. So you just have to type the message and press enter. Now all these records are published into the Kafka topic. Now let's instantiate the consumer and then consume these messages from the topic. So I'm going to create a new window. Similar way, when I need to go to the bin folder of the Kafka distribution, and then I'm going to do ls-ltr. There is a consumer script similar to produce script, which will help me make this consumer listen to the topic that I just created. So I'm going to copy the script from the GitHub repo. So in here, if we take a look at it, I'm using the console consumer.shell script, followed by zookeeper details, followed by the topic name. We have created the topic as my topic 1, and then we are passing another attribute called from beginning, meaning this consumer is going to read the messages from the beginning. Okay, I'm going to run it. So if you take a look at it, this consumer read the messages whatever we posted into the Kafka broker from the console producer. Let's see, let me post some other messages. Hello consumer, how are you? See, as soon as I posted the message, the consumer picked up the message from there. Let's launch another consumer, but not passing the from beginning value at the end of the script, and let's see what happens in this scenario. I want to open another window. So what I'm going to do is I'm just going to copy this value, paste it, then give this topic that we created. I'm not passing the from beginning value. See, it did not read any of the messages that was previously posted into the broker. I'm going to post some new messages now. New message. So if you take a look at here, the new message is consumed in the old consumer, and the new message is consumed in the new consumer too. Meaning this consumer listens only to the latest messages. This consumer reads from all the messages that were available in the Kafka topic. So we have this flexibility available in the Kafka consumers, which make Kafka unique from other systems. There is one another important concept called commit log, which I will briefly explain in the upcoming tutorial, but I would like to show where is this located. So I'm going to close this consumer. So there is a attribute called log.directors which is available in the server.properties, which is inside the config folder of the Kafka distribution. So I'm going to go to the root /tmp/Kafka logs ls. So if you take a look at here, this is a folder which gets created. You see there is a time index, log file and an index file. If you take a look at here, this the name of this folder is the topic name followed by the partition value. So if we have two partitions, then there will be two folders available. The second folder would be my first topic 1-1. If we have three partitions, then there will be another folder which ends with 2. So basically it creates a log folder for each and every partition that is available for this particular topic. Let's see what is the content which is available in the log. So if you take a look at it, these are the messages that we posted. Hello, how are you? But this log is not exactly in a readable format because it has a lot of other contents just logging the messages. We will Kafka commit log. This is one of the important feature in Kafka. Let's recall the statement from the Kafka documentation. Each partition is an ordered, immutable sequence of records that is continually appended to a structured commit log, meaning each record that gets published will have an offset value and the offset gets increased by 1 for every new record. For example, in this diagram, the first record has an offset value of 0. The following record have the offset value incremented by 1. In Kafka, each and every record that gets published commits a transaction to a physical commit log, which will have the complete list of activities in the sequence they are published. You can relate this to a DB commit log in the database world. Using this transaction commit log, you can completely replicate the topic even in a totally different broker. Kafka achieves the replication and reliable behavior using this commit log. Let's take a look at the log file which is located in /temp/Kafka logs, which is defined in the server.properties file. So if you take a look at the server.properties file, this is where exactly the location where this commit log file will be available. So I have this consumer and producer up and running from the previous tutorial. I'm going to post something to it, and this will eventually gets committed to the log file which is located in this folder. The folder is /temp/Kafka logs and then the topic name and the partition ID appended to it. Kafka uses for its operation. There are totally 4 core APIs, and they are Producer API, Consumer API, Streams API, and Connect API. Let's talk about each API in detail. Let's start with the Producer API first. We have seen examples of how to produce and send the message to the Kafka topic using console producer in the previous tutorials. What happens behind the scene actually is the console producer uses the producer API to publish the message to the Kafka topic. We will have hands-on session on how to implement producer using Java in the upcoming tutorials. Next, we will talk about the consumer API. We have seen examples of how to consume a message from a topic using the console consumer in the previous tutorials. Behind the scenes, what actually happens is the console consumer invokes the consumer API to pull the data from the topic. We will have hands-on session on how to implement the consumer using Java in the upcoming tutorials. Okay, let's talk about the next API, which is a Streams API. Suppose, let's say you have a use case where you have to read the message from a topic and move it to another topic. So we are not going to do any processing after we pull the message from the topic. We are just going to transfer the message from one topic to the another topic. In these scenarios, the Kafka uses a Streams API to push the data from one or more input topics to one or more output topics. We will have a hands-on session on this one in the upcoming tutorials. Next, we will talk about the Connect API. The Connect API are used in scenarios where you need to continually pull from some source data system into Kafka or push from the Kafka into some other data system. The usage of Connect API is very less. Behind the scenes in brokers, zookeeper, producers, and consumers in Kafka. Let's talk about the create topic command. Here, unlike the hands-on on the create topic command, we are initiating the topic command with two partitions and the replication factor as 1. The call first goes to the zookeeper, and the zookeeper, which maintains a complete metadata information about the Kafka cluster, finds out the available brokers and creates a topic and assigns the partitions in the available brokers. In this example, we have a multiple brokers scenario. Partition 0 gets created in broker 1 and partition 1 gets created in broker 2. As we discussed before, topic can expand to multiple brokers. The metadata information that is available in the zookeeper will be sent to the brokers also, as you see here. So as a distributed system principle, each broker talks to each other using the gossip protocol. So here, each broker knows which partition is owned by which brokers. In the background, even the brokers, they send health status to zookeeper, as you see here. So this is to make sure if any of the broker goes down, whether any activity needs to be taken care by the zookeeper or not. We will talk about what happens behind the scenes when producers and consumers. Let's talk about producers first. When the producers tries to connect to a topic, ideally it should know at least address of one of the broker in the cluster because each broker has knowledge about other brokers and the partition it owns in the Kafka cluster. The metadata information will be shared back to the producer. Now the producer knows which partition is owned by which broker. The partition in which the record is going to sit is decided by the producer based on the key and value it is sent as part of the record. We will talk about partitioning mechanism in the future tutorials. So this is a way producer communicates with broker. Let's talk about consumers here. When consumers tries to connect to a topic, it connects to the zookeeper first and pulls a metadata information about the topic and which partition it resides in which broker. Consumers use this information to scale simultaneously and process the message simultaneously using a popular concept called consumer group, which is one of the important topic I'll be covering in the later tutorials. Once it receives the information, then it connects to the topic which is configured as part of the Kafka consumer and start reading the messages from it. How to run multiple brokers in your machine. So when you downloaded the Kafka distribution, we noticed there was a server.properties file. We can relate this one like one server.properties file is equivalent to one broker. So in order to have many brokers, you need to have many server.properties file with a unique name. In this example, I'm going to show you 3 brokers running in my machine. So in here, I have created 2 additional server.properties file with the name server1.properties and server2.properties. So I just copy and pasted it and then renamed it. And in order to make each property to behave like one single broker, there are some additional changes that needs to be done. I'll show you what are all those changes. So the changes will be the broker ID and the listeners and the advertised listeners and then logged out directories. So if you take a look at it, the other 2 properties file will have the broker ID as 1 and the listeners port as 1993, but if you take a look at the other one, it is 1992, and the advertised.listeners will have the port as 1993, and then it will have a different Kafka logs folder altogether. Same here for the third server2.properties. I'll show you how the changes are going to look like. So this is the actual server.properties file, and this one was commented before. Now we have enabled this, and the port is 1992, and the broker ID is 0. Here the port is 1992 for advertise.listeners, and then the log directories, the value will be Kafka logs. So in the server.properties file, we have changed the broker ID to 1, and then we have changed this port from 1992 to 1993 for listeners and advertise.listeners. And for the Kafka, for the log directories, we have changed the value from Kafka logs to Kafka logs 1. Similar way, in server2.properties, we have changed the value from value to 2, and then the port is changed to 1994, and here the advertise change .listeners port is also changed to 1994, and then the log directories is changed to logs 2. Okay, now we have the configuration setup done. Let's run the brokers and Zookeeper. So here I'm in the bin folder of the Kafka distribution. Let me copy the Zookeeper commands from here. So I'm gonna copy the Zookeeper command and then run this in my local. Okay, now we have Zookeeper up and running. Let's run the Kafka broker. So this command is going to be the same because we have a properties file with the same name. The name is server.properties. So I'm going to launch it. I'm right now in the bin folder of the Kafka distribution. Okay, one of our broker is up and running. Let's try to run the second one, but in here we need to change this value to 1. So let's run it. Okay, now we have the second broker up and running, and then now we are going to launch the third broker. So it's going to be 2. Okay, now we have 3 brokers up and running, and now what I'm going to do is I'm going to create a topic and then see how this topic is going to get created. In here I'm going to copy the command from here. So in here what I'm going to do is sometimes it copies the tab space. Okay, in here I'm going to change the name from my first topic to my second topic, and then I'm going to increase the partitions to 3 and replication factor also to 3. Okay, so let's issue this. Okay, I'm not in the bin folder. Let me go into the bin folder, tkf1, and then now I'm going to run this. We are creating a topic with 3 partitions and 3 replication. The replication factor value is 3. Now it created the second topic, and then we will see how this topic is going to look like using the describe command. So we have the describe command here. In here you see there are 3 partitions, right? Each partition has a leader. Who is the leader? We can relate a leader to a broker. I would like to explain about the leader, replicas and ISR in a separate tutorial. Now let's try to publish some messages and see what happens to the broker. So here I'm going to use a console producer, which is part of the Kafka distribution. So I'm going to copy the console producer command. I would like to connect to the new topic that we created, that is my second topic. Okay, now I want to publish. Okay, hello. believe there is some problem here. How are you? Replication. Okay, now these three messages are posted into the Kafka broker. Now what I'm going to do is I'm going to read it from the Kafka console consumer. So there is a console consumer script that is available. I'm going to use that script. My second topic. Here it is going to read from the beginning. Okay. Okay. One interesting thing to notice. If you take a look at the order that we posted here, we start with hello and then how are you and then replication. But if you take a look at here, how are you was read first and then the replication and then the hello. The order is totally um, uh, different. The reason being each message is posted to a different partition. So when the consumer reads the messages from the partition, it reads in a different order. And the reason is ordering is only guaranteed within the partition. It is not guaranteed outside the partition. Now we have three partitions. Just by looking at it, I can tell you each message lives in different partitions. Now what I'm going to do is I'm going to bring down the one of the broker and then see how it behaves. I'm going to bring broker number one, meaning broker with server one dot properties. Let's see how the producer and console consumers and producers behave. So I brought this one down. Okay, it's down now. I'm going to issue a describe command and then see how the configuration looks like now. In here you see this node, the leader 1 is no more available, and then leader 0 took care of taking care of the partition 1. Now for partition 1, leader 0 is a leader. So, and if you take a look at it, the in-sync replica value is reduced to 0, 2. So what Zookeeper does is, as soon as the broker goes down, Zookeeper is smart enough to know something has happened, and then it reassigns leader. For each partition there should be a leader, and it reassigns the leader 0 for this partition 1. And Kafka consumer did see some error, but still it did not go down. Now I'm going to post some messages and then see whether the Kafka consumer is still able to read the messages or not. See, the message is still consumed by the consumer. What happened is here in the consumer level, basically there needs to be some kind of reassignment that needs to be done, and then once that reassignment is done, it is going to start listening to the partitions as like it was. Replication factor and ISR. ISR stands for in-sync replica. Let's talk about leader first. In the world of distributed system, each server in the system needs to talk to each other in order to maintain the state of the cluster, which is in the Kafka world called as quorum. So when a broker is created, there will be a leader assigned to it by the zookeeper. This leader is responsible for communicating to other brokers about the partitions it owns. This leader is also responsible for maintaining the data in that broker. So let's take a look at this diagram. Zookeeper assigns a leader for each broker. So when a create topic command is issued, then the zookeeper assigns a partition to the available brokers and maps a leader to it. Each leader knows about other leaders in the cluster and the partition each leader owns. So I'm going to demonstrate this using an example. What I'm going to do is I'm going to have the multiple broker running in my machine. So if you take a look at it, I have it up and running already. So you have the zookeeper. The first window shows the zookeeper, and the next three windows are the Kafka brokers. I'm going to create a topic now with multiple partitions and replication factor value greater than 1. So in here, Okay, I'm just looking for a create command. So here I have the create topic command. I have the partitions given as 3 and the replication factor value given as 3. So I have made a lot of samples. So I'm going to create a unique name. The name that I'm going to use is my fourth topic. This is my fourth topic in this cover distribution. Okay, created the topic, my fourth topic. I'm going to describe. So if you take a look at it, this is the topic that we just created, and there are 3 partitions, and each partition have a leader to it, meaning this leader is responsible for maintaining the data in this partition. Let's take a look at the replica. Here, this leader is responsible for maintaining the value of partition 1, 2, and 0, meaning this particular leader owns this partition, but it still have the replica of 2 and 1. Same is applicable for the other 2 partitions also. Partition 1 is owned by leader 2 and partition 2 is owned by leader 0. Still, the replica of all the partitions is available in these topics, meaning in these brokers. So I'm going to produce some message using the console producer. I believe everyone is familiar with this at this point. So I'm going to give the topic okay, right now I'm going to publish some messages. Hi, hello, how are you? My spelling mistake, it's my bad. And blah. So I have published these 4 messages. If they are in the same partition, then in that case, when the consumer consumes it, the order will be maintained. When the consumer consumed and the order is not as we published, then it means the same, it is the value is, the messages are published to multiple partitions. Here, one interesting thing to notice, we have passed just the 1992. 1992 corresponds to one of the broker in the server properties file. The other 2 host values, meaning the other 2 port values are 1993 and 1994, if you remember from the previous tutorial. So here I'm gonna consume the value from beginning, and the topic value that I'm gonna give is 4th. Okay, I have published it. If you take a look at here, hi is the first message, that's correct, and the next message is hola. Why? Meaning this message is pulled by the consumer from the other partition. It is not part of the same partition. So one interesting thing to notice, here we just passed the 1992. How did it connect to the other 2 brokers? Meaning this is achieved because there is a quorum in place. Each leader knows about the other leaders in the cluster and the broker and the partitions they own in this particular Kafka cluster. So when the message is published into the Kafka cluster, basically each message have a key. Based on the key, it will be pushed to the appropriate partition. We will talk about the different partitioning mechanism when I discuss about producers in detail. Okay, with this we came to the end of the leader concept. Let's talk about replication factor. So replication factor, this value should be always greater than 1 for any topic. This makes sure it is going to give you higher availability, stronger durability, and fast tolerance. This is mainly to guarantee that any published message will not be lost at any point and will be consumed even though there are broker failures, server failures, or program errors. Let's take a look at this diagram. If you take a look at this diagram, broker 1 owns the partition 0, but still the replica of the other partitions are available in the broker. Meaning when the record is published to partition 1 or partition 2, which are owned by broker 1 or broker 2, but still the replica of it will be placed in broker 1 also. Let's say one of the broker goes down. In this case, zookeeper will assign the partition 1 to either leader 0 or leader 2, meaning broker 1 or broker 2, and the data that was present in broker 2 will be available as a replica in both the brokers. So there is not going to be any data loss. It's wonderful, isn't it? Let me demonstrate you with an example. So in here, we see partition 0 is owned by leader 1, and it still has a replica of 0 and 1 and 2. I'm going to bring one of the broker down and then see how it behaves. So this is broker 0, broker 1, and broker 2. I'm going to bring broker 1 down. You see here, there is some exception that you see in the Kafka consumer, console Kafka consumer. The reason being, when one of the broker goes down, this consumer was ideally connected to all the three brokers. When one goes down, there needs to be a reassignment that happens. And with this, the reassignment happens in the background and you get all these exceptions. But still, this program did not go down. I can prove you that. The way I can prove it is, I'm going to post some messages. Hello consumer, are you alive? See, it still reads the message. But one more interesting thing is we need to look at the configuration of the replication configuration of this whole topic, how the reassignment happened and who owns which partition. So if we take a look at it, we brought the leader 1 down and leader 2 owns the partition 0. And there is no way we are going to lose some data. The reason being the replication factor made sure all the data that was available in leader 1 was available in leader 2. This is one of the benefit of having this replication factor always greater than 1. Okay, with this we came to the end of the replication factor. Let's talk about ISR. ISR stands for in-sync replica. This value, the ideal scenario is the ISR should be equal to replication factor, meaning this value and the ISR replication factor and the ISR should always be equal. If you take a look at the initial scenario, the value is sync. It means both the all the brokers have all the brokers have the replica of the other brokers, meaning they are in sync. All the brokers have the data that needs to be replicated. And now we brought one of the broker down, and then the in sync replica reduced to 2, meaning there is something going on in the system that needs to be looked at. There is some intervention required in order to bring the Kafka cluster to the healthy state. So in any situation, replica factor and in-sync replica should always be equal. So this is the ideal scenario. So I have provided the link here. I'm using Eclipse Luna for this tutorial. So you can just go to the browser and then type Eclipse Luna for Java EE developers, and then it will take you to this link. So based on your operating system, you can either download 32-bit or 64-bit. For this demo, I'm using Mac, so I'm going to download the 64-bit version. Just click on the download button. It will give you the distribution. For the purposes of saving time, I have downloaded this already. So now I'm going to show you how to create the workspace in your local. Just type Eclipse. If you are using Windows, you can just type Eclipse in your startup. So if you click Eclipse, and then it will give you the default workspace. You can just open that, and if you want any specific folder, you can create the folder and use that folder for workspace. Now we have Eclipse launched in our local machine. So in this presentation, if you take a look at it, I have mentioned something called terminal. The reason why we need this is it is going to be easy to learn Kafka if you have terminal downloaded as part of Eclipse itself. So it's just like another software. You just have to go to the Eclipse marketplace and then download this plugin from there. So I'm going to go to the Eclipse marketplace and then type tm terminal. Okay, it is taking some time. That's unusual. Okay, let me close this. Okay, we got it. So if we type tm terminal, there will be a plugin which will be available here. So I have installed this already, so that's why I have this uninstall button. If you have not installed it, you will have an install button here. Once you install it, you have to restart Eclipse. Once you are done restarting and installing this plugin, just press Ctrl Alt T in Mac. I think there is a similar key available for Windows. So it will give you the terminal window so that you can run all those Kafka consumer, Kafka producer shell scripts here. That's the benefit of it. Kafka producers are the key for the operation of Kafka. This is a component which kicks off the complete Kafka workflow. So in here, I'm going to use Eclipse for this tutorial. Here, I'm going to create a Kafka producer. So for that, I'm going to create a Maven project. Maven, in simple terms, we can call Maven is a build tool which is used to define dependencies, download the dependencies for the project, and build the artifact for the project. So I'm going to create a Maven project. I'm going to select other here, type Maven. So I'm going to select the Maven project, and then I'm going to check this create simple project. So in here in the group ID section, I'm going to give com.learn Kafka. And in the artifact ID, I'm going to provide value called learn Kafka. So artifact is nothing but when you completely build the project, when you try to build this project, it will give you a WAR file or a jar file or a EAR file. For this project, it will be a jar file. So the name of the jar file, the final artifact, it's going to be learnkafka.jar. For the group ID, so group ID is something like, I would like to explain this using an example in an enterprise. In an enterprise, let's say you have many departments, for example, accounting, transportation, digital, and a lot of other departments like that. For example, if you are part of the accounting department, then this group ID will be com dot your portfolio, com dot your company dot your portfolio, for example, if you're part of accounting. So your group ID is using the group ID, you can determine so to which group this particular project belong to. For now, I'm gonna just give a learn Kafka, and then I'm gonna click finish. So Maven here, it gives you all the default project structure, meaning the package structure. So in the source main Java, you can provide all the source files, meaning the .java files. In the resources folder, you can provide all the .properties file. In the test Java Java package, you can provide all the JUnit test cases and all those stuff. So I'm gonna create a class. Before that, I want to create a package called com.producer, learn Kafka.producer. So once you have this created, now let's create a class called producer Kafka. So we have the class created. Now we need to create an instance of the Kafka producer, which will actually used to connect, which will be actually used to connect to the actual broker. I have the code already available in the GitHub repo. I'm gonna just pull it, and then I'll explain you the code line by line. I'll share you this code link also. So in here, there is a main method. Okay, let's walk through this code. So, okay, there are a few compilation issues. I'm going to resolve those. I'm going to import the java.util.properties, and then it complains about Kafka producer. So in here, Kafka producer is something which is part of the Kafka library. So we need that library. How can we get that library? So there is a dependency that you can provide in the Maven project that will actually download that dependency for you. So I'm going to go to the pom.xml file, and then I'm going to download this dependency and use it in the code base. So I'm going to open the pom.xml and then provide these dependencies inside the project tag. Now we have provided the dependency. Let's see whether is it, see, as soon as I added the dependency here, it went to the Maven centralized repository and pulled the dependency and downloaded the dependency and added the dependency to this project. So here I get this Kafka producer import, which is part of the arg.apache.kafka.client.producer. So I have it imported, and now next is the producer record. Let's import this also. This is also part of the arg.apache.kafka.clients. Now all the compilation issues are resolved. I will walk you through the code line by line. So in here, the first three lines here are Bootstrap servers. We are using a properties object. Basically, it is like a key value pair, and we are populating these three attributes, which are the mandatory attributes that are required in order to connect to the Kafka broker. So bootstrap.servers, you need to provide the broker address against this property. So now the Kafka producer knows which broker it needs to connect to. Next is a key serializer. Key serializer is one of the property, if you recall from the previous tutorial, in behind the scenes of producer and consumer, the key is the one which decides which partition this particular message is going to be allocated. This property instructs how to turn the key objects the user provides with their producer record into bytes. What do I mean by producer record? I will cover this in a moment. We need to mention which serializer is used in this producer so that the consumer can create an appropriate deserialized object in the consumer end to deserialize it. Next comes the value.serializer. For value.serializer, this works similar to key.serializer, but this holds the actual payload of the data. So there are a lot of other producer configurations that are available in this below link. Let's look at the code now. Now, if you take a look at the code, now we have covered this part. Next is a Kafka producer instance. This is an instance to which we will pass the properties. Properties are the ones which holds all the broker details and the serializer and what key serializer and value serializer. So we create this Kafka producer instance. Now we have the connection available to the Kafka producer, and we need to create the message and send this message to the Kafka producer, to the Kafka broker actually. So in here, this is achieved by calling the send method. So when you call the send method, that's when the record gets published into the broker. Now let's talk about producer record. I mentioned earlier, I will explain you about what is a producer record. Producer record is an object in Java that needs to be populated to send the record to a Kafka topic. Here we did not mention any partitioning mechanism, so it is going to use the default round robin approach to push the message to the topic. As I mentioned, when this send call is made, actually the message is going to get published into the Kafka broker. You must close the producer instance and call after calling the send method. The reason being you might end up having connection leaks if you don't close it. I'm going to run this and then see how it behaves. Before I do that, here the producer record takes many parameters. I'm going to remove this for now. I'll explain you why I removed this. So in here, if you take a look at the implementation of this, the first argument takes a topic, and the next argument takes a key, and the next argument takes a value. Key takes the string value. As you mentioned, we are using string serializer, and then the value is the actual payload that we are sending. So I'm going to create a topic for this particular example. So here I have the zookeeper and broker up and running. You need to have a zookeeper and broker up and running if you want to publish any message to the Kafka broker. For this example, I'm going to create a topic called demo topic. Now we have created the topic. Let me take a look at the descript command and then see what is the configuration look like. So if you take a look at it, this is a demo topic that we created. There is one partition and there is one leader assigned to it. So now I'm going to change this to demo topic. So what this code is going to do is it is going to iterate. I'm going to change this to. It is going to iterate 50 times. It is going to iterate 50 times, and it is going to publish the message with message value is equal to integer.toString. The value will look like message value colon 1, message value colon 2 until 50. Okay, I'm going to run this program. Okay, now the messages are published into the Kafka broker. How can we validate this? How can we validate this producer successfully published the messages into this particular broker? Okay, I'm going to run the console consumer, which we have used in the previous tutorials. So I'm going to copy the command from the GitHub repo. This GitHub repo is very handy, and you can use it when you are going through these tutorials. So in here, I'm going to read from the beginning. So I'm going to change the topic value to demo topic. I messed it up. Let me do it from the beginning. So in here, so I'm going to remove the my first. I'm going to give demo. Now it is pulled all the messages, whatever we posted. See, this confirms the messages, whatever that got published from the from the producer is read by the Kafka console consumer. So how to alter the configuration of a topic? I'm going to do a describe and then see what are all the topics that I have in my local Kafka cluster. So I have a topic named demo topic that is available, and the partition count is 1. I'm going to alter the configurations for this particular topic. I'm going to change the partition count from 1 to 4. How do I do it? So there is a command that is available. You can change any attributes that are part of the partition using that command. So the command is available in my GitHub repo. As I mentioned in many of my tutorials, I'm maintaining all the Kafka commands in a GitHub repo. I'll share you this as a reference so you guys can use it when you guys are running it in your local. So in here, what is happening is I'm passing a attribute called -alter to change the configuration of a topic. So and then I'm passing the topic and then I'm passing the actual topic that is going to get impacted, and I'm changing the partition values from 1 to 4, and I'm passing the zookeeper as a argument to this /Kafka topics.sh. So if you are using Windows, it's pretty simple. Use the Kafka topic.bat. There is a batch file that is available for this purpose. So I'm going to run this. Okay, adding partition succeeded. So meaning it successfully added the partitions. Let's describe the partition and then see how it looks like. So here the partition count increased from 1 to 4, and you see all these partitions are created, and then the leader is 0, meaning this particular topic was created against one single Kafka broker, and we did not make any changes to the replica, so it stays as is. The partitioning mechanism in a producer, which is one of the key concepts in Kafka. This determines which partition will be allocated for each and every message that is published by the producer. The partition strategy is completely determined by the key value that is passed as part of the producer record. It is not advisable to leave the value blank. There are totally 4 different approaches available. Let's discuss about it one by one. Approach 1 is by providing the partition number, which is a direct approach. Basically, you just provide the partition number as part of the producer record, and all the records will get posted into that particular partition. Let's have a demo on that. So if you remember from the previous tutorial, we changed this demo topic value from 1 to 4. So right now, if you remember from the previous tutorial, I have removed this value. I will explain you the significance of that now. So here, I'm going to give the value as 0. What this particular change is going to do is it is going to publish all the messages to the partition 0. And I would like to take you inside this producer record and then see what are all the different implementations or different instances that you can create. Right now we pass the partition, and then it creates a producer record which takes the 4 arguments. The first one is a topic name, next one is a partition, next one is a key, and the next one is a value. So in the previous example we used this particular instance, meaning the integer value is passed as, meaning the partition value is passed as null. It just takes a topic, key, and value. Okay, let's run this program and then see. I have the Kafka console consumer up and running. I'm going to run this program. If you see, as soon as I publish the message, all the records got posted to the partition 0, and Kafka consumer is able to read from it. But it did not say which partition this particular record is read from. So I would like to explain this. Let's save it for now. I would like to explain this in the Kafka consumer tutorial. So what I'm going to do is, right now we know there are 4 partitions, right? So 4 partitions have the value 0, 1, 2, 3. I'm going to give the value as 4 and then see how it behaves, because this partition is an invalid partition. It is not, there is no partition available with the value 4. Let's run it. Here, if you take a look at it, the partition range is only 0 to 3, but you are passing 4. It will throw you an illegal argument exception. So with this, we came to the end of this approach. Let's discuss the next approach. The next approach is the round robin. No key and partition is provided as part of the producer record. In this case, this will follow a round robin approach, meaning it chooses the partitions in a round robin approach. For example, if we have 4 partitions, it will publish the message to the first one, partition 0, and then partition 1, partition 2, and partition 3, and then it continues the cycle. Let's have a demo on that. So what I'm going to do is I'm just going to remove these key and partition value. Okay, I'm going to clear this. So okay, for a change, what I'll do is I'll change this value to 50 and 100 or 75. So it's going to publish 25 new messages. Let's see, let's run this. As soon as I publish the message, basically all the messages are published into it. But the interesting thing, if you notice here, it is not read in the order it was published. But if you take a look at the other one, we published all the messages to one single partition, so the order was maintained. But if you take a look at here, it is followed the round robin approach. It published each and every message to a different partition, and the consumer consumed it parallelly, meaning consumer listens to all the partitions. So it does not take the order. It just pulls the messages from different partitions at the same time. So if you take a look at here, all the messages are not ordered. So this confirms partition followed the producer followed the round robin approach and published the messages to different partitions. That's awesome. With this, we came to the end of the round robin approach. Let's take a look at the next approach. The next is a key hashing. So if you provide a key and there is no custom partitioner implementation, then the partition is decided by this formula, key.hashcode divided by number of partitions. So I will explain you the custom partition implementation in the next section. But there is a drawback to this approach. If the key is the same for every record, then some of the partitions will never receive any message. And in here, from the previous example, when I showed you the initial demo of Kafka producers, I would like to correct a small mistake which I made in the previous tutorial. I mentioned it takes a round robin approach if you provide a key as part of the record. That's not true. If you provide a key, then it uses the key hashing mechanism to determine the partition. So let's have a demo on this one. So in here, what I'm going to do is I'm going to pass the key. The key is going to be message 1, or let's have the key as message, right? And then I'm going to change the value from last time we gave it as 75. This time I'm going to give 101 150. Let's publish this. So if it is going to be, if this key is going, I believe the key is the same. Let's see how it behaves. Okay, if you take a look at here, the order is maintained. The reason is we are passing the same key, and it follows this formula key dot hash code slash number of partitions. Every time this key is going to be the same, and it is getting published in the same to the same partition. So since it is published in the same partition, the ordering is guaranteed, meaning the order whatever we published, it is pulled in the same order by the consumer, meaning the message is not published to multiple partitions. This is awesome. So with this, we came to the end of this approach. Let's discuss the next approach, which is the custom partition implementation. So in the place of custom partition implementation, we need to provide a custom class that is going to take care of this partitioning mechanism. This can be done by providing the implementation class against there is an attribute that we need to provide. The attribute is partitioner.class. So partitioner.class is an attribute to which you can pass your own Kafka partitioner. So in here, basically what we need to do is I have to create a class called partitioner. So if you take a look at here, this takes the partitioner value com.learnKafka.partitioner .producer Kafka partitioner. So meaning this is your custom class which is going to be part of this package. So I'm going to copy this implementation from one of the class, meaning I have it in the GitHub repo. I'll share you this repo details. So this class have to implement the partitioner class and then it will ask you to implement the methods. So in this one, you can implement your own partitioning mechanism, and then this will be considered if you pass the partitioner class and give the class in your own package, so that this takes care of which record needs to be in which partition and all those concepts. So this is not the scope of this particular implementation is not the scope of this tutorial. Kafka consumers, the component which actually reads the messages from the Kafka topic. Let's code the Kafka consumer in Java as part of this tutorial. I have the code already available in my GitHub repo. I will share the repo details so that you can use this as a reference. I'm going to copy the code from there. So it's available in this repo, and if you have to go inside this Kafka folder, meaning Kafka project, and then go inside the consumer, and this is a class which we are concerned about. So here I'm going to copy the contents from here. Don't worry about the code. I'll be explaining the code line by line. So here I have the class created in our previous app, and the class name is consumer Kafka. So I'm going to paste the contents whatever I copied from there. Okay, so there are a few compilation issues. Let us resolve it one by one. I'm going to import the java.util.properties, and then it is complaining about Kafka consumers. This Kafka consumer is also part of the Kafka client, which we added as a Maven dependency. And then we have to import the RLS package. And then similar to a producer record in Kafka producer, we have a consumer record here. So I'm going to import that. And consumer records is an object which will hold the list of consumer record. Okay, now we have resolved all the compilation issues. Let's walk through the code line by line. We'll discuss about the properties that we have set here. And we are passing these properties to the Kafka consumer. Kafka consumer class is a class which will actually make the connection to the Kafka broker. This class is required, and we have to pass the mandatory properties or meaning mandatory attributes to it, so that it can make the connection to the Kafka broker, and in turn it connects to the topic. So let's discuss what are all the different properties that we have. So in here, the first one is a bootstrap.servers. You need this. You need to provide the broker address against this property. Basically, Kafka consumer works differently from Kafka producers. Kafka consumers first interact with the zookeeper and get the list of broker address, and then it connects to the appropriate topic, whatever we are instructing the consumer to do. And followed by that, we are passing the key.deserializer. This property instructs how to deserialize the key that was published from the producers. This needs to match with the one from the producer. If you remember from the previous tutorial, we have passed string serializer. So here we are using the string deserializer. Next is the value.deserializer. This is similar to key.serializer, but the actual payload will be read from this one. This needs to match the one with a producer. Apologies for the typo here. So group.id. So as per the documentation from Kafka website, this group ID is a unique string that identifies the consumer group this consumer belongs to. So this is I would like to explain the importance of group ID as a separate tutorial. This is a concept which is used for scaling the consumers. Okay, let's go to the code. In here, we are creating the instance of Kafka consumer. So as I mentioned before, this is an object which will actually make the connection to the Kafka broker and then to the topic. So, and then we need to mention which topic this particular consumer is going to listen to. So here you provide the topic that we are interested on. So if you remember from the previous tutorial, we created a topic called demo topic, and we are going to use the demo topic for this example. And then once you have this topic defined in this array list, you have to pass that array list to this subscribe API. So what it does is this line is making sure this particular consumer is going to listen to this topic. So you can give n number of topics against this particular subscribe call. So the next one is a consumer record, and the consumer record is returned from the poll call. So here I'm going to change the value to 1000. I will explain you why. So similar to the send call in the Kafka producer, we have this poll call. This is a call which actually starts the whole consumer flow, meaning this is a call which pulls the records from the Kafka topic. So let's see what will happen behind the background when this call is made. So when this call is made, basically the first step is consumer sends a heartbeat to the cluster, which makes sure this consumer is an active consumer. So the broker, as soon as the Kafka receives the heartbeat, then it will validate this consumer and make sure this is an active consumer. If no heartbeat is received within the session.timeout.ms, then the cluster will invalidate the consumer, and the rebalance will happen in the consumer end. So here we are passing the poll 1000. Basically, this call will spend 1000 milliseconds, meaning 1 second, to poll the records in the Kafka cluster and fetch the consumer records back to the consumer. Once the records are fetched, the consumer will continue processing the records further, and once it reads all the records, meaning once it completes the processing of all the records, then it will do the same process, because we have a while loop here in place which is gonna wait for this call to complete, meaning once the records are pulled, it will process the record. Here we are just printing the records. Once that is done, it is again going to make the poll call. During that time, a heartbeat will be sent to the Kafka cluster to make sure, okay, this consumer is an active consumer. In addition to this, I would like to explain two key properties. The key properties are enable.auto.commit equal to true, and auto.commit.interval.ms is equal to 5000 milliseconds. What this means is records are committed and offset is periodically increased every 5 seconds, meaning this operation will happen in the background of the consumer. It will basically commit the transaction, meaning this is like a DB transaction in a database world. Basically, this will commit the offset. So I would like to explain this using an example. So you have this consumer up and running. For example, for some reason, the consumer has gone down. Then in that case, when it comes up, meaning when you bring the consumer up, it reads the message from the last committed offset. This will make sure you are not rereading the message again. There is a way to manually commit the offset by changing the enable.auto.commit equal to false. I'll show you a demo on this one in the next section. One quick catch is that when you don't set the properties, meaning here we are just setting the 4 properties, right? There are a lot of other attributes that needs to be set when a consumer is constructed. So if you don't give those values, by the consumer will take those values by default. So yeah, now we have completely constructed the consumer. What we will do is we will try to publish some records to this consumer and then see how the consumer behaves. I'm going to run this consumer. Now we have the consumer up and running. So here I have the console producer up and running. In here, what I'm going to do is I'm going to post some messages. Hi consumer. How are you? So I have posted 2 messages. The consumer read those messages from the Kafka topic. So here what we will do is we will discuss about each and every attribute that a consumer record holds. The first one is a topic. This refers to the topic to which this record belongs to. Next is a partition. This refers to which partition this record belongs to. Next is the offset. Offset refers to the offset value of the record. If you take a look at the offset value, it is different for each record. This confirms the producer is using the round robin approach to push the message to different partitions. And this is a confirmation that each partition maintains different offset value. Next is the create time, the time the record got created. Next, we will talk about the serialized key size, the total memory of the key in which the memory of the key in number of bytes when this was encoded in the producer end. Here the value is given as -1 because we are publishing the message using the console producer and there is not an option available to pass the key. The next one is a serialized value size. So the total memory value, that is the payload in a number of bytes when this was published in the producer end. Okay, now if you take a look at next is a key value is null as we discussed, and the value is the attribute which actually holds the payload. For example, if you are just concerned about value and you want to read that value and then you want to process it for further movement of the message, meaning you want to store this message in the DB. So you just get the actual payload using this record.value and you pass this message to further processing. Maybe you can just push it to another Kafka topic, or you can just commit it using you can commit the value into the DB or something like that. So now what I'm going to do is I'm going to pass the key. So in here, if you take a look at it, we have used the producer in our previous example. What I'm going to do is I'm going to pass some value, and I'm just going to iterate this loop 2 times and then produce 2 messages, and I'm passing the key as message. Let's run it. Okay, so here what is complaining is invalid value for the partitioner configured. Okay, so here we have the partitioner configured. We are not using any fancy custom partitioner, so I have uncommented that. And then now I'm going to run the application. So it produced 2 messages. So as soon as it produced the 2 messages, the consumer picked it up from the Kafka broker. Here, if you take a look at it, here we are passing the same key. So it got posted into the same partition, because it is using the key hashing approach, meaning the actual key dot hash code percentage the number of partitions. So every time it is going to give you the same partition number and then same value so that it gets posted to the same partition. And if you take a look at it, here the serialized key size is 7 bytes. The message, when it got encoded into byte, basically we are using the string serializer. When it got serialized, the size of that serialized message object is 7 bytes. And next, if you take a look at the key, the value is message, and the actual value that we posted is message value 1. I believe now everyone have the complete understanding of how producer and consumer works, and we have implemented the actual producer and consumer using Java on how to automatically and manually commit the offset from the Kafka consumer. Before we dive into manual offset management, I would like to explain about automatic offset management and the issues because of the automatic offset management. By default, if you don't set these values in the consumer will have these settings set. That is, enable.auto.commit equal to true and auto.commit.interval.ms equal to 5000 milliseconds. So in the previous example, we did not set these values. So the consumer actually considers these default values and commit the offset to Kafka in the background. What are the issues of offset commit management, automatic offset commit management? Let's consider this scenario. After the message is read, the attributes of the message should be persisted into the DB, but the DB is down for some reason and the message is not persisted into the DB. But we have this enable auto commit set as true and it commits the offset to Kafka every 5 seconds. Ideally, the message is not processed successfully, but the offset got moved because of the default feature. We have seen the example for this one in the previous tutorial. Now let's discuss about manual offset management, meaning you have the complete control of when to commit the offset. To enable this manual offset management feature, we need to have the enable.auto.commit value equal to false. And there are two methods that are available to the Kafka consumer class. The methods are commit sync and commit async. So we can use these methods to commit the offset to the Kafka. Let's code the consumer which manually commits the offset. So in here, what I'm going to do is I'm going to create a class. The class name is consumer Kafka manual offset. So I have the code already available in my GitHub repo. I'm going to copy it and then I'll explain you the code line by line. So if you take a look at the consumer package, I have this consumer Kafka manual offset. I'm going to copy the whole code. So there are some compilation issues. I'm going to resolve those issues. And then I'm going to import the Kafka consumer. I'm going to import the array list. And then I'm going to import the consumer records object. Okay, now you see here, this is the method call from the which is part of the Kafka consumer, which actually commits the offset to the Kafka. So we need to have this method if you are going to enable the offset management. And one of the key parameter here is we have this enable.auto.commit is equal to false. When you have this value set, basically you are just promising to the Kafka cluster stating this consumer is going to take care of the offset management. So what I'm going to do is I'm going to bring this app up. So now we have these values. Okay, one interesting thing. The topic that we are interested in is demo topic. So let me give the topic. Okay, I'm gonna run this. Okay. So now I have the Kafka console producer up and running. I'm gonna publish some messages. I'm gonna publish the messages 1, 2. So right now we have published the message into the Kafka consumer, and then the Kafka broker basically, so the consumer read the message from it. If you take a look at it, the key is null. That is expected because the console producer does not have any feature to provide the key as part of the message. So these are the messages that we published, and the messages are read from the consumer. So what I'm going to do is I'm going to bring this consumer down and bring it up to make sure whether it is not rereading the message, whether the commit is successful or not. So I've brought it down and then I'm going to bring it up again. So now I have it up and running. So if you take a look at it, it did not read the messages 1 and 2. If this commit was not successful, basically it would have read from the beginning, meaning it would have read the message 1 and 2. So I'm going to publish some more messages. So I published the messages 3 and 4. Now the Kafka consumer is going to read those messages from the topic. So you see just 3 and 4 is read. What I'm going to do is I'm going to comment this code. So basically I'm going to comment it, kill the Kafka consumer. I'm going to comment this. So I have commented this. Let me run the consumer again. So I'm going to post two messages, 5 and 6. So now this consumer is going to read those messages, but there is no code available here in the consumer that is going to commit the offset back to the Kafka cluster. Let's see how the system is going to behave. I think the consumer is taking more time than usual. Okay, now it read the messages 5 and 6, right? So what I'm going to do is I'm going to kill this. We have not committed the offset from the consumer. So I'm going to kill this consumer and bring it up. What will happen is it is again going to read these messages. So I'm going to clear this console. So now we have the consumer up and running. So I'm just going to post some message and then see whether it is picking the messages 5 and 6 or not. The consumer is trying to pull this message. Okay, so if you take a look at it, it read the message 5 and 6 again. So this is what I was saying. If you don't commit the offset, basically what will happen is it will reread the messages. So this is one way of manually managing the offset. For example, let us say this scenario, you read the message from here and then there is some issue happened in the DB. So basically this method call will not happen. So if you have the code like this, if the message persistent, meaning you read the record and then you persist the record into the DB, if there is some problem with persisting the data, so in that case the consumer will not reach this line and it will error out here itself and will go to the exception block. This consumer still did not commit the offset. So when you shut down the system and then bring it up, what will happen is it will reread the message where it was left off, meaning when was the last commit offset. So yeah, this is a way we can manually manage the offset from the consumer. So about consumer group and its benefits. So what is a consumer group? Consumers that have the same group ID setting in the Kafka consumer forms the consumer group. Let's take a look at this attribute in the code. So if you take a look at this example which we used for our earlier tutorials, there is an attribute called group.id and it has a value called test1. And if you have if you have another consumer class and which has the same group ID setting, and if both of these class files are up and running, then this forms a consumer group. You might be asking this question, why consumer group? Okay, let us consider this example. If we have 100 partitions for a topic and you have only one consumer to read from these 100 partitions, this puts a lot of overhead for the consumer. If the consumer goes down, then there is no way we can process the messages real time, and someone have to manually intervene and bring the app up so that it can start consuming the messages again. So we need to scale out the consumer and make each consumer read from different partitions in the same topic, and all the consumers should be in sync with other consumers that are reading the messages from the same topic. How can we achieve this? This can be achieved by consumer groups. This will help in achieving high throughput and fault tolerance at the consumer end. Next, let's talk about group coordinator. When Kafka determines that there are multiple consumers that have the same group ID and they are subscribed to the same topic, then Zookeeper selects a broker from the list of brokers that are available in the Kafka cluster as a group coordinator, and its job is to monitor and maintain the consumer group. If the consumer goes down, then this group coordinator takes care of reassigning the partitions that was handled by the consumer to the available consumer in the consumer group. This will help in achieving the fault tolerance. If the group coordinator does not receive any heartbeats from the consumer, then this will invalidate the consumer and it rebalances and assign the partition to the available consumer in the consumer group. If any new consumer joins the consumer group, then the group coordinator takes care of distributing the part of the partitions from the existing consumers to the new consumer. If any new partition gets added to the topic, then there will be a rebalance initiated by the consumer coordinator and the new partition will be added to the consumer group. Okay, let's start coding. So in here, what I'm going to do is I'm going to create a package called consumer group. Click other, type package, click next. Here dot consumer group. In here, what I'm going to do is I'm going to create 3 different classes. So class number 1 is consumer group 1, consumer Kafka 1, consumer Kafka 1, and next class is consumer Kafka 2. Click on class. Kafka 2. Number 3 is consumer Kafka 3. So now we have 3 classes created. Now let's have some implementation in here. So what I'm going to do is I have a code repo in GitHub which has all the code. So I'm just going to copy the code from there and then paste it here. I'm going to go to the GitHub repo, and then if you go inside this Kafka, okay, my internet is damn slow. Okay, I'm going to go inside the Kafka. I'm going to go inside this. There is a package called consumer group. I've created these 3 classes. I'm just going to copy it from here. Copying the whole main method. I have to resolve all these compilation issues. This is done. Here, if you take a look at this, 2 changes. One is this: I have added this localhost 1993 also as part of the bootstrap.server. It is always advisable to give more than 1 brokers if you're running this consumer or your producer against a multi-broker system. It is always advisable to provide more than 1. For example, if one of these is down, then automatically it will try to connect to the other one and get all the metadata information in the producer end. In here, I'm going to change the topic to demo topic. That's done. So one more interesting thing to notice, as part of consumer group, if you're having multiple instances of consumer group up and running at the same time, ideally this group ID should be unique. I'm going to copy the same code in the next consumer because we need to maintain the same group ID in order to participate in the consumer group feature. Okay, that is done, and this is done. Now we have 3 consumers. We have created 3 consumers and all the consumers have the same group ID. What I'm going to do is I'm going to add console views have 3 console created. I'm going to run this first program. Okay, if you take a look at it, consumer 1 up and running. I'm going to open the second console. So I have to pin few things. If you take a look at it, this one is having Kafka consumer 2, so I'm gonna select this and then pin this one. So this one is consumer 1 and this one is consumer 2 now. I'm gonna run the third consumer. So I'm going to pin consumer 2 in the second window. So if you take a look at it, first one is consumer 1, second one is consumer 2, and third one is consumer 3. What I'm going to do is we have all these 3 consumers up and running which are listening to demo.topic. What I'm going to do is so I have the console producer up and running in here, and I have the zookeeper and 3 brokers up and running. So this partition, this topic have 3 partitions in it. I believe 3 or 4 partitions. Let us publish some messages and then see. So this one was picked up by the consumer Kafka 3. I'm gonna print this message. This one is picked up by the consumer Kafka 2. I'm gonna publish one more message. This one is again picked up by the consumer Kafka 3. You see here, consumer Kafka 3 read 2 messages out of the 1 message, and consumer Kafka 2 read the message that is from partition 3. I'm going to post one more message. I believe this is going to go to the consumer Kafka 1. Okay, so here now all the 3 consumers have messages in it, meaning this particular consumer is listening to partition 2, and this particular consumer is listening to partition 3, and this particular listener is meaning this particular consumer is listening to partition 1 and partition 0. So if I post any message again, whatever the message that are published into partition 0 or partition 1, that will be picked up by the consumer Kafka 3 instance. So in order to make it more fun, I'm gonna publish some 250 messages in here. And what I'm gonna do is I'm not going to pass any key, so that it will follow the round robin approach, and it will publish publish the message to all the partitions. Okay, all these are going to publish to localhost and demo topic. Okay, we have published 250 messages. Let's see how these messages are allocated into it. This is the advantage of having multiple instances. You see, all the messages are processed parallelly. This is what I was referring to in our theoretical conversation about consumer group. We can scale out the consumer so that you can have very high throughput. So if you take a look at here, this particular consumer reads all the partitions, all the messages that are pushed to partition 2. This particular consumer reads all the messages that are pushed to partition 3, and this particular consumer reads all the messages that are pushed to partition 0 and partition 1. So the consumer, as soon as all these 3 consumers came up, the zookeeper found out that these 3 consumer groups have the same group ID. So eventually what it did was, okay, all these 3 are having same group ID, then let's assign a consumer group coordinator. So this consumer group coordinator, what it does is it takes care of assigning some set of partitions to each consumer. So it assigned partition 2 to consumer 1 instance, and partition 2 to consumer 1 instance, and partition 3 to consumer 2 instance, and partition 0 and partition 1 to consumer 1 instance. So with this, we can achieve a parallelism and high throughput. For example, let me bring one of the consumer down. For example, I'm going to bring consumer Kafka 3 down. Okay. So right now, okay, did I just close the console, or I just close the console? What I'm going to do is I'm going to bring it down. Right. So I brought it down. Now we have consumer Kafka 1 up and running. Let's see whether consumer Kafka 2 is up and running or not. Okay, consumer Kafka 1 is listening to partition 2. Consumer Kafka 2 is listening to partition 3. What I'm going to do is I'm going to publish another set of messages. What I'm going to do is I'm going to publish some 250 messages again. Okay, and then I'm going to run the program. So I ran the program. It published 250 messages. If you take a look at here, earlier this particular instance was listening to only partition 3. But after we brought that third instance of the consumer down, it started to pick up the messages from the partition 2. Let's take a look at this one. Earlier, it was just listening to partition 2. Now, if you take a look at it, it is listening to partition 0 and partition 1. This is where the rebalance comes into picture. The Kafka consumer coordinator does the rebalance, and it recognized, okay, there is a consumer that was that went down, so let's reassign the partitions to the existing consumer. So eventually what it did was it reassigned the partition 0 and partition 1 to the consumer 1 instance, and partition 2 and partition 3 to the consumer 2 instance. So this is very dynamic. Whenever it sees any kind of abnormal activity, the consumer coordinator takes care of reassigning, doing the rebalance and assign the partitions to the existing consumers. So here I'm using the same consumer Kafka 1 class which we used in the previous tutorial, but in here what I'm going to do is I'm going to run just a single instance of this class. And we discussed about the consumer group and its benefits. This this tutorial is going to be just the group ID and what are its impacts. So if you take a look at here, the group ID is group 1, and I have created another group called demo group, and the partition value is just 1. And what I'm going to do is I'm going to bring it up and then see whether it is reading. There is a console producer here which is up and running, from which I'm pushing the messages into the Kafka broker. So when I bring the app up, basically it read all the messages from the producer, meaning whatever the messages the producer pushed into the Kafka topic. So I'm going to publish some more messages. So it is reading all the values. You see, it read until 8 before, and then I published 9 and 10. It read those messages. I'm going to keep publishing some more messages. So it read all the values. And let us say your use case, you have some issue in your end, and you want to read all the messages from the beginning from this topic. So in that case, what you will do, what are all the different approaches that we have in Kafka? There is one approach which might help in these kind of scenarios where you want to read all the messages that are there in the topic. Okay, let me bring this one down, bring this consumer down. What I'm going to do is here, if you change a group ID, what will happen is it will think of this consumer as a fresh consumer, and all the offset and everything would get reset for this particular topic. Let's see, I'm gonna bring this one up and then see how it is going to behave. You see, here it read all the messages that were there in this topic, 2, 3, 4, 5, 6, 7, all the messages, whatever it was there in the topic, it read all the messages from it. So this is one of the advantage of group ID, meaning if you want to consume all the messages that are there in the topic, then the way to do it is change a group ID in the consumer and then deploy the app. So it will read the messages from the beginning in that particular topic. So this is applicable if you have multiple consumer instances. Change a group ID. So in the case of multiple group instances, In that case, there will each and every group will own some set of partitions. So you have to change a group ID in all the consumers. Eventually, it will read the messages from the beginning from each and every partition. We will talk about how to reset the offset value to a specific value in the Kafka consumer and read the messages from that offset value. The use case or the example scenario that I am going to consider here is read the message from the Kafka consumer and from the Kafka topic and store that message in the DB. So the scenario is the DB is down or you have some bug in your code. So in that case, you have read the message, but you did not persist that message or you did not process the message for further processing. So in that case, you need to reread the message from the topic to process the message again once you have all the issues in your application end is fixed. Let's start coding the consumer part. So in here, what I'm going to do is I'm going to create a class. The class name is consumer Kafka reset offset. And then I have the code that already available in the GitHub repo. I'm going to copy the code and then I will explain you the code line by line. So in here we have the code. And we are going to resolve these compilation issues. We'll import the consumer records and then we are going to import the consumer record here. Here we are not going to manage the offset. Basically we have set that enable by default the enable.auto.commit.offset is equal to true, meaning the offset commit is going to be it will happen in the backend, in the background basically. So in this case when I bring the consumer up, there is no fancy code here. It is going to just read the record. So in the example scenario I mentioned we are going to purchase the DB, but in this code let us assume this is a line which is actually printing the data into the DB. I'm going to bring this consumer up. For the purposes of this demo, I have created a topic called demo.reset topic, and then I'm going to read them. I'm going to bring this consumer up. Now this consumer is up and running. I have the Kafka console producer instantiated and it is ready to push the messages into the topic. So I have pushed the message 1 and that message is read by the Kafka consumer. I'm pushing one more message 2, so it read the message. Now I'm going to bring this consumer down and then bring it up and then see how the consumer behaves, because we have enabled that auto commit offset. So this consumer would have commit the offset by now. Basically it will not read the messages number 1 and number 2 again. If you take a look at the value of the offset value of number 1 is 0 and the offset value of value 2 is 1. Okay, I'm going to bring this consumer down and then I'm going to bring it up again. So and I'm going to post a message to see whether it is not reprocessing the messages 1 and 2. So I posted the message, the consumer is listening to the topic, and then it is going to read the message from the topic. I'm not sure why it is taking more time than it is intended. Okay, now if you take a look at it, the value 3 is read, but the value 1 and the value 2 is not read. The reason being those are committed in the backend by the Kafka consumer because we had that enable.commit.offset set to true. Okay, now what happened was when you process the message 1 and 2, basically you had some issues in the backend, meaning when you try to process the data into the DB was down or there is some bug in your code. Now you want to reread the messages again. So there is a way you can do that in Kafka Bolt. That is not the case in any of the existing messaging solutions. For example, if you consider topic or queue, as soon as the consumer reads the message will be kicked off of the topic or queue. Let's do the code here. So in here, I have commented few codes. I'm going to uncomment those codes. First thing is you have to create a topic partition object. So this topic partition object is an object to which you pass the topic name, the actual topic, and then you will provide the partition. So if you take a look at our code, we have only one partition. So this particular topic is created with only one partition. So for this instance, you pass the topic name and the partition. So the topic name is demo reset topic, and the partition value is 0. And in consumer, there is a method called seek. So what it does is, when the consumer comes up, basically you can seek the consumer to read from the, this is if you take a look at the seek method, it takes the partition and the offset from which you want to read it from. So let us say when you read the messages 1 and 2, you had some issues, so you want to reread the messages. So if you remember from the example, the value of the offset value of 1 is 0. So what I'm going to do is I'm going to give the value as 0 and then see whether it is going to reprocess all the messages, because when you set the value as 0, what it is going to do is it is going to read the messages from the first message, meaning the value from the value is 1 is the first message, which has the offset value of 0. I'm going to run this code. I'm going to clear the console and let's run this code. Okay, see, you see here, right? When we did not have this code and when we brought the consumer up, basically it did not read the messages 1 and 2. But if you take a look at it now, since we have reset the offset value to 0 and we requested the consumer to read the values from offset, read the records with the offset value 0, it read the messages again. So this is one of the terrific feature of Kafka, which exists only in the Kafka messaging system. This is one of the very big advantage of Kafka. Basically, whenever you want to reprocess the message again, the message stays there in the Kafka topic until the retention period. So until that point, you can reset this offset to any value so that you can reprocess the message again, and you can basically you can reread the message again from the topic and then process the message again. So with this, we came to the end of this tutorial. Okay, before I end, I would like to explain there are two other seek methods that are available in the Kafka consumer. The methods are seek to beginning and seek to end. Seek to beginning, what it does is basically you have to pass the collection of partitions so that it will read. So all the partitions, whatever you're sending as part of the collection, it will read from the beginning of that partition. Seek to end, what it does is if you based on the partitions that are part of the topic which you are passing, it will just read the latest records from that particular topic. So there are few key properties I would like to highlight in this tutorial. The first one is the session.timeout.milliseconds. By default, the value of this one is 10,000 milliseconds. If no heartbeat is received, then this will remove the consumer from the consumer group, and the group coordinator will take care of rebalancing the partitions that are owned by this particular consumer to the available consumers. Fetch.max.bytes, the maximum amount of data the server should fetch for a poll call from the Kafka consumer. So when a poll call is made, basically based on this value, it pulls that many number of bytes. Maximum poll records, the maximum number of records that should be written in a single poll call. And next is SSL. If you have a secure topic, then below attributes are required to be set in your Kafka consumer. The first one is the protocol, which needs to be set to SSL, and next one is the trustor location. This will hold the client trustor JKS file against this property. Next is the trustor password. This will hold the password to access the trustor file. Next is the key store location, and next is the key store password, and next is the SSL key password. So you need these 6 attributes if you are going to access a secure topic. There are many additional configuration properties that are available in the below link. I highly recommend you to go through this below link. Explore about the Kafka GUI client tool named Kafka tool. If you have worked against the Oracle database, you might have used something like SQL Developer or tort to connect against a DB and run some SQL queries against the same. This is a kind of a similar client tool to connect to the Kafka cluster and manage the clusters, which is really handy, and you can also create and delete a topic using this tool. This tool runs on Windows, Linux, and Mac OS. Let's download and install the tool first. The installation is straightforward. Okay, go to Google Chrome or any other browser and type Kafka tool and then hit enter. So you will be taken to just click on this link which has a website name called www.kafkatool.com. Go to this link and then this is a home page of the Kafka tool, and go to the download section. So based on your appropriate operating system that you're using, download the appropriate Kafka tool version of it. So here I'm using Mac. I'm just going to click the download. So if you're using Windows, use if it is a 32-bit, then download, click on this link. If it is 64-bit, then click on this link. If it is Linux machine, then click on this link and it will download the file for you, installation file for you. So basically the installation is straightforward. It's like any other installation file that you install in your machine. So for the purposes of saving some time, I have installed the app and I have opened it here. So in here, you see, okay, I'm going to delete this one too. I'm going to create the connection from the beginning. Please disconnect the connection first. So what I'm going to do is I have my Kafka broker and Zookeeper up and running. So I'm going to shut down the broker and delete this connection. Okay, it is asking me to disconnect and then delete the connection. So when you open your Kafka tool in the beginning, so it'll look fresh and brand new, no connections configured in it. So the first step that you're going to do is you're going to click on this and then add connection. Give a name, like I'm going to give the name as localhost, and here I'm going to start the broker. So with this, I have both Zookeeper and broker up and running. And in here, I'm going to select the 0.10 version, that is the version which I have in my local. And then here I'm using the plain text, mine is not SSL secured for this example. I'm not using any SSL or any crazy configuration, it's just straightforward. I'm just gonna click on test. So it says connection is successful, do you want to add this connection? I'm gonna click yes on that. Now you have the connection saved. Now you want to connect to that localhost. Okay, let's see what we have. Let's see what we have in our brokers. So this is a broker which is up and running in my local. Let's see what we have in my topic. Nothing. Let's see what we have in my consumers folder. Nothing. So what we do is we will just create a topic now. So if you remember this GitHub link which I have shared in my previous tutorials, where I'm maintaining all the different commands that I use throughout this tutorial. So here I'm going to create the topic. So the topic name is my first topic and configuration is straightforward. I have a replication factor set as 1 and number of partitions set as 1. Click enter. Now the topic is created. Let's take a look at it by checking this, by running this configuration to list the topics that are running against this, that are created against this broker. So it displays there is one topic that is created. The topic name is my first topic. Let's go to the Kafka tool and then refresh this. You see here the Kafka topic is created. So when you click on this, basically it will give you three tabs. First tab is the properties, what is the kind of the topic name and what will be the key and message in the topic name. Next is the data, it is brand new, there is no data, so it's empty. Next is the number of partitions. We have given the partition value as 1, so the partition that gets assigned is 0 and the leader for that particular partition is localhost 1992. Now what we do is, so the consumer is empty and there is no data in this topic. So what I'm going to do is I'm going to publish some messages. For that I have to instantiate the console. I'm going to instantiate the console producer and then publish some messages into it. So this is in console producer, and then I'm going to connect to localhost 1992 and then publish some messages to the my first Kafka topic that we created just now. So now it is connected. I'm going to publish some messages. Hello, how are you? Now these messages are posted into the topic. Let's see whether the Kafka tool is able to pick those messages or not. You see here, two messages got posted into the partition 0 because we have only one partition, and both have the offset value as 0 and 1 respectively. And if you take a look at the message, it is completely the encrypted message, so it has some binary values. Now you see this Kafka tool, it is able to pick whatever that is available in the Kafka topic, and then it is able to display the messages in a UI. So now what we do is we'll just instantiate the consumer and then see how the consumer looks like in the Kafka tool. Then go to the, I'm just going, yeah, I just came to the same link and then I'm going to read from the beginning. So I'm going to copy paste it here. If you take a look at it, it read all the messages. Now let's refresh this consumer and then see what this, how this configuration, how does this folder looks like. See, this consumer got created and it tells you it assigns ID to it, and then the consumer type is Kafka, and the offsets are stored in Zookeeper. So these are the values basically that gets populated in the consumer folder, and the tool is very handy. Just by taking a look at it, for example, you might be posting something and then the message did not reach the broker. You can just reference this and then see whether the message is actually sitting in the topic or not. This is one way of validating the messages in the topic, and you can validate what are all the different topics you have against a broker, and what are all the different brokers you have against the Kafka cluster using this GUI tool. And this tool is very handy, and I highly recommend this tool to anyone who is working on Kafka topic. So I'm going to show you a scenario where I'm going to delete the topic from here and then see how the configuration is going to look like. So it will ask all data in topic will be lost. Are you sure want to delete the selected topic? I'm going to click yes. Topic successfully marked for deletion. So I'm going to refresh this. Okay, so for some reason it is not getting refreshed. Let's run this command and then see how does the configurations against this broker looks like, meaning does it displays any topic or not. So for that, how to check the configurations of all the topics, I'm going to run this command and then see whether the topic is still sitting in there or not. So the topic is not deleted yet. Why? What is the reason behind that? Topic will not disappear immediately. So it does tell you the message. Okay, doesn't. Yeah. Now if you take a look at it, the topic is removed, and then these consumer offsets get stored. I'm going to delete these two. So I'm just going to try to refresh it and then see. Okay, all are deleted. And then what I'm going to do is I'm going to run this same command, which will give me the list of topics, topics that are available against a broker. Now if you take a look at it, it doesn't return any value. So this is for sure the topic got deleted from the broker. Yeah, this tool is really handy. You can manage different operations. You can perform different operations against a broker, and even you can delete the broker also. And there are stuffs like that you can do with this tool. I highly recommend this tool to anyone who is working on Kafka. Let's start with YCaml. Any application in an enterprise today needs to talk to different applications or different departments. Eventually, what this means is there needs to be some integration in place in order to interact with each system. Integration always involves some challenges. New technologies come up all the time to solve these integration issues. We already have a lot of technologies such as web services, messaging, and etc. to solve these problems. But if you take a look at the core of the problem, there is always a pattern behind these problems. Those are grouped together as enterprise integration pattern. Apache Camel implements all those enterprise integration patterns. Let's talk about what is Camel. Camel is a lightweight integration framework, and it is an open source project licensed under Apache Software Foundation. Camel offers support for multiple DSLs. When I say DSL, DSL stands for domain specific language, and it supports multiple languages such as Java, Scala, Groovy, and Spring. In the world of technology, there are n number of protocols, and Camel provides support for more than 80 protocols. When I say protocol, let us say HTTP is a protocol, and FTP is a protocol, and Kafka has its own protocol. So different technologies have different protocols, and Camel supports almost all the protocols that are out there. And Camel is easily configurable to most of the components out there. And Camel can handle any kind of payload. Basically, if you take a look at a SOAP web service, it is restricted to for only XML. So there is no restriction with Camel. It supports any kind of payload. So let's code a simple use case, and then we will discuss about Camel architecture, and then we will code the Kafka clients in Camel and see how it interacts with the Kafka broker. The use case is that we are going to read the files from a folder and write the file into another folder. Let's code it. So I have Eclipse open. So let's create a new project. It's going to be a Maven project. So I'm going to select the create a simple project. I'm going to give the group ID as com.learnCamel. So the artifact ID is going to be learn camel simple. You can leave rest of the part as it is and then click finish. So now we have a project called learn camel simple. So I have the code already available in the GitHub repo. So I'll be providing the link for that repo. So if you take a look at it, let's go to the this is a project which I created, learn camel simple. So all the projects that are related to this tutorial will be available under this repo, teach Apache Kafka. Go to the Apache pom.xml. So this is a dependency that we need to add. So if we go to the pom.xml and then add this dependency, so I need to copy from here. So now we have the camel dependency available for our project. Let's code it. Let's create a package called com.learnCamel. And in here, what I'm going to do is I'm going to create a class or create another package called file. So basically, we are going to read a file from a folder and then copy that file into another folder. So click on finish. Did I create a file or a package? I want this to be inside camel. Okay. So now we have this available. Right now, let's create a class. So I'm going to just copy the code from here. I will explain the code line by line. So this is a file that I'm going to create. Go to other, type class, and here give the class copy files camel. So now let's go one by one. We need a main method. So in order to run any camel application, basically you need the camel context. Camel context is the runtime. So I will explain you about the architecture of a camel in the next tutorial. Let's code. You don't need to know the complete architecture in order to have a simple working program in Camel. So let's code it first, and then let's discuss about the architecture in the next tutorial. The reason why I have kept architecture in the next tutorial is that if you if you understand an example, that will be quite easy to understand the architecture after that. So the first thing, as I mentioned, we need the context. Let's import this. So it is saying it is not able to find the context. Ideally, the dependency should be available by now. Okay, what I'm going to do is sometimes I get into these kind of issues. So basically I have all these imports available here. So it is complaining the arg.apache package is not downloaded. Let's see what is going on here. I think I made a small mistake over there. Yeah, I have provided the project the close tag in here, so that's why I did not download the dependency. So now let's go and take a look at it. See, now all the compilation issues are resolved. The first step is to define the context, and next step is to create a route. In Camel, everything is a route. A route is something like, okay, from where, that is the from, and there will be a to. So basically, from is where is the source for that particular camel. That's the starting path, and to is the destination path. So how can we, right now we have the camel context available. How can we create a route? So there is a simple code for that. So I'm gonna just copy this. So if you take a look at it, with the context, we got the camel route engine, meaning that's the runtime we need. And then we are adding routes to it. The way you can add route is that you can create a route builder, and the route builder will have a method called configure. In the configure method, you have to provide two lines basically. So one is a from, and next one is a to. From, what it does is basically, so what is the source for this route, from where this route should start. So it should start from data slash input, and then if you take a look at the file, so here the use case is to copy a file, and then copy that file from this location, data slash input, to send this to the destination data slash output. So the idea here is, in Kafka, the first part of the, we call the whole thing is a URI. So in Kafka, this whole thing is called as a URI. So what this URI has is, the first part of the URI specifies the component that you're going to talk to. For example, if this is a Kafka topic that you're going to interact using this route, then it will be Kafka. So there are behind the scenes, basically it refers to that component, whatever you refer here. So here we have provided file. So behind the scenes, what it is going to do is, it is going to refer to the file component, and then it is going to read the data in this directory, data slash input, and then no opt true. This is the option which you can provide as part of the camel. This is the syntax for any kind of URI. So from takes a URI, and then to takes a URI. So from URI is where you're going to read the file, to URI is where you're going to place a file. A URI, the whole thing is a URI in camel world. So now we have added a route. Let's see what are these compilation issues. I'm going to surround it with try catch. And then what is the next step is, once you have created the route, so basically you need to start that context. So here we have created the context, and once the context is created, we have to start the context. Once you start the context, that's when this route will get picked up, and then this route will do whatever operations that we have instructed it to do. So here the instruction is that go to this folder, copy the files, and then paste it in this data slash output folder. See what is this giving us. I'm gonna throw that exception. And then what we have to do is once the context, once we started the camel runtime, we have to give a thread.sleep. So basically we have to let the thread to sleep so that the camel will have enough time to copy the files from this folder to this folder. And once the file copy is done, we'll stop the context. So now we need to create these folders, data slash input and data slash. We don't have to create the data slash output. What camel does is if it doesn't find the directory, it creates the directory automatically. So I'm gonna create a directory called data, and I'm gonna create another directory called input. So as I mentioned before, no op instructs the camel not to perform any operation after it copies the file. If you don't give it, basically it will remove the file from this data slash input folder and then put that file in the data slash output folder. So basically we are instructing camel not to do any activity, just keep the file stay there. Let's create a file. File1.txt. So here I'm gonna give some messages like hi, hello, how are you. So now we have the context created and we have created the route, and then here we are starting the context and we are asking the thread to sleep for 5 minutes so that camel will have enough time to copy the file from that folder to the destination folder. Once that is done, we are stopping the context. Let's run this example and then see how it works. So now the camel is running behind the scenes. Now the thread is asleep for 5 seconds. Now the thread is okay. The context is stopped now. Let's refresh this project and then see whether it really copied the file. There you go. Here it created the output folder and then copied the file from the data slash input, and it pasted the file in the data slash output. Let's see what happens if you don't give this no op equal to true. You might be wondering what will happen, right? Let's run this. So I'm gonna delete this folder itself. Okay, it is done its operation. You see here, right? It removed that file and then it did create a backup called .camel folder and then kept the file over there. If we don't give this options, basically by default it creates this .camel folder and keeps a backup file over there, and then the file got moved automatically. File got moved to the destination folder. You see, the camel code is really simple. For example, if you don't have camel and if you have to write a plain old Java class in order to copy a file from one location to the another location, so what you have to do is basically you have to open a stream, you have to read the file and then construct a file object, and then you have to create an output stream and then write it to the output stream and write the file to the destination location using that output stream. So basically there is a lot of coding involved. With Camel framework, basically you can simplify a lot of things. Basically it requires is a from and a to. So even with Kafka, it's going to be the same. Instead of the file component, we'll be using a Kafka component. So before we get into constructing the Kafka clients using Camel, let's talk about the Camel architecture and different components that are part of the Camel architecture. Let's start with the route engine. This is a component responsible for moving the messages which runs behind the scenes. So we have seen in the previous example, as soon as we started the context, basically it started the camel started its whole process. So behind the scenes, there is a route engine that takes care of moving the file from one location to the another location. But that is something which happens behind the scenes. The next thing is the route. So route sits inside the route engine. So a route is the one which defines what needs to be done as part of this camel project. So the simplest way to define a route is a sequence of processors. So we saw a route in our previous example. The route is like from this location and to this location, right? So from is one process and to is another process. It's like, as I mentioned here, a route is a chain, a chain of processors. So from is a processor and to is another processor. You can have any number of to it, and you can add. There are a lot of different concepts in Camel, which is not part of the scope for this course. There are something called process, and there are a lot of transformation components that are also available as part of Camel. We will not be covering all those things. So in a simple way, a route is something which you can relate to a sequence of processors. And next come the DSL. DSL stands for domain specific language. Basically Java supports, basically Camel supports Java, Scala, Groovy, and Spring. So I mentioned uh, a route is a chain of processors, right? Let's take a look at a simple. So a processor, this whole thing, the from and the URI, whatever that is sitting inside the from, is one processor. So basically, if you add something like .2, that is another processor. A route is like a chain of processor. This is what I was explaining earlier. The next comes the component. So component, we have explored about the file component. So there are a lot of other components such as JMS, JDBC, Kafka. So Camel supports over 80 different components, and we will be covering Kafka component in the next tutorial, and rest of the other components like JMS, JDBC, and other components are not in scope for this course. What is an endpoint? So I explained about endpoint in the previous tutorial itself, but let's get into a little deep inside that one. So an endpoint is divided into three parts. One is a scheme, and next one is a context path, and next one is the options. So let's explore this endpoint. So file is refers to the scheme. So basically you instruct Camel, okay, use a file component for this kind of operation, and then consider all the different options that are related for file. So in file, if you give a component as a file, basically it will look for a folder. So the folder is data/input, which is nothing but the context path here, and followed by that you can provide a number of options. So if you go to the Camel website, you can find a lot of other options. Here we have just explored the no op equal to true. Basically what you inform Camel is that do not perform any activity after you complete the route. So this is about the endpoint. Let's take a look at the architecture. So we have covered this part, we have covered this part. Next is a message based processors. So this is also we covered. That is what I was referring to, processors. I mean, the example that we looked at is a simple example. Just copy the file from one location to another location. There are, if you want to manipulate the message after you read the file from the location, there are options for that. Those are not part of the scope of this course. So let's discuss about these things in a separate course. Next is a content-based router. So that even this component is not part of the scope of this course. So basically what is a content-based router processor is that you can perform some activities based on the content. For example, if you have a XML, if you have a JSON, or if you have a plain text, do certain activities based on the type of the file. You can do that using Camel. How to create a Kafka consumer using Camel. So these are the steps that we will be following as part of this tutorial. The first thing is to add the Camel Kafka and logging dependencies into the pom.xml, and followed by that we will define a route for the Kafka consumer. So the route looks like this. So here you have the from component, and the from component you use the Kafka component. If you remember from the previous tutorial, we have used the file component. Here you have to instruct the camel to use the Kafka component, and followed by that you give the topic name to which you're going to connect to, and followed by that you'll give all the options. The options here are, first one is broker. You just instruct the Kafka consumer to which broker that it needs to connect to, and number of consumers, that is the attribute is consumers count. And next to is seek2. Seek2 is the attribute which tells Kafka to from where it needs to read from, and does it have to read from the beginning or does it have to read the latest. And next is a group ID, and followed by that we have a route ID, meaning for this route the ID for this route is from Kafka. And then, so in any real-time scenario, basically after you read the message, you might be persisting that data into the DB after you read the message from the Kafka topic, or you might be passing it to some other downstream systems. The downstream systems could be a API call, or it could be another Kafka topic, or it could be queue. Lot of other downstream systems are available. So but here for this example, in order to keep it simple, we are just logging the message whatever that is read. So the way we can do that by using the log processor, and then you just print the whole body into it. So yeah, let's get into the coding part of it. So I have the Eclipse open. I've created a project called Learn Camel Kafka. So as I do in the other tutorials, I have the code already uploaded into the GitHub repo. Let's go to the GitHub repo. So in here, the first step is to add the dependencies. So here, these are the dependencies: the camel core dependency, and then the camel Kafka, and followed by that we have all these logging dependency. See, if the code here is like you have you might be seeing similar kind of code available in other GitHub repos. So if you go to the camel website, camel GitHub repo, you can find a lot of other examples for other modules. So I'm going to copy the whole thing. So now we have all the dependencies copied. Now what we are going to do is we are going to create a route. In order to create the route, we need the class file. So first let's create the package. Okay, I'm going to go to so the complete code is available in this project, Learn Camel Kafka. Camel Kafka client. I'm going to create the similar class. Go to other, type class, and then give the class name, click finish, and then give the main method. If you remember from the previous tutorial, the first step is to create the context. So let's resolve all these compilation issues. Okay, same problem, whatever I got earlier. So in here it is complaining. See, I did not copy the dependency stack. Okay, believe this would have resolved the issue. Yep. Okay, import the default camel context, and followed by that import the camel context. So once these are done, so now what we'll do is we will we'll create the route. That is the next step. So let's create the route. So the route is pretty straightforward, as I mentioned in the presentation before. So in here, it's around let's try catch. So in here, you use the Kafka component. If you remember from the previous example, we have used the file component. So this is to instruct Camel to use the Kafka related modules, and it looks for, I mean, all the Kafka related modules will be available inside this camel Kafka library, which we have included as part of the format XML. And then what you mention is the other attributes are the brokers to which it needs to connect to, and next is a number of consumers count, and seek2 is the beginning, meaning read the messages from the beginning, and next is a group, and then you're assigning a group ID. So this part is done. Right now we have the route created, and after that we need to start the context, and then we need to have the thread, meaning do not close the context as soon as it is started. So here what we are doing is we are having this consumer up and running for 5 minutes. So here we have the consumer up and running for 5 minutes. So this consumer basically, as soon as it comes up, it is going to listen to that Kafka topic for 5 minutes, and then it is going to shut down. So for the purpose, I mean, I have created, for the purposes of this tutorial, I have created the topic already, and then I have the Zookeeper and the broker up and running. Here I have my console producer. In order to test this feature, I have the console producer up and running. One important thing that we missed is like we need to add the log4j2.properties, because we have the logging configurations available in the format XML. The logging configurations looks for this log4j2.properties as part of the class path. So let's create that. log4j2.properties. So now let's go and copy the configurations from the GitHub repo. So now we have everything set. Right now this consumer, I have posted some messages already to the topic. I believe it is going to pick up those messages as soon as I bring this consumer up. Now you see, right? Yeah, it pulled all the messages. Since we have defined as beginning, the seek2 is given as beginning, it pulled all the dependencies, I mean all the messages that were there in the topic. So here we have the Kafka consumer, which is using the Camel framework, and then this consumer is connecting to the Kafka broker using the Camel framework, and then it read all the messages from the Kafka topic. Let me push some messages from here. You see here it pulled the message from there. So you here we have mentioned the route ID, right? So if you take a look at it, the route ID is from Kafka. So with this, we came to the end of this tutorial. I mean, you can find this code samples in the Apache Camel GitHub repo. If you go and take a look at it, you will be able to find the updated examples, because people who are supporting this Camel Camel project, they keep updating the latest versions and the latest consumer examples over there. Okay, let's create a class called so create a class Camel Kafka producer. As I do for the other, as I did in the other tutorials, I have the code already pushed to the GitHub repo. So if you take a look at it, the class is Camel Kafka producer. So let's create the main method first. So in the main method, we will give this Camel context. Let's define the Camel context, and then let's import the libraries. So once this is done, similar to the consumer, here we have to define a route. So that is the next step. Let's create the route. I'll explain you the code line by line. Let us resolve all these compilation issues. So it's compiling, change it to final. I'm just doing it. Syntax error on catch. Why? Oh, there is no try. Yeah, I'm not going to do this now. I'm going to let the code do that. Okay, let's walk through this code. So here we have created the route. The route is from direct equal direct colon push to topic, and we are giving the route ID as direct to Kafka. We can change this to producer Kafka. So I'll explain about this direct component in a moment. The scenario here is uh, we have to define the Kafka component. Kafka component is a class which is part of the camel, and then it takes the broker address, and then this is when you produce something. Basically, this is a component which lets the camel know, okay, which broker this needs to connect to, and here you define the topic. So here we are using the Kafka component and you define the topic. So the wiring between the topic and the server happens by setting the Kafka component to which broker it is gonna connect to, and then push the message to this particular topic that is defined here. So I mentioned I'll explain about direct in a moment. Let's go to the code base and then copy the remaining code. Okay, let me resolve all these compilation issues. So in here, producer template. Producer template is something which is part of the camel library, which is used to produce something and then push it to an endpoint. So if you take a look at the producer's behavior, it requires some event. So based on that, it produces the messages and then send that message to the topic. So here, this is a standalone producer. So basically, it requires some input to that producer so that it can, I mean, not an input. It requires an event. So for that event, it can react to that and then produce a message. So here, if you take a look at it, direct is a component in Camel. So basically here, we will be pushing something using this producer template to this endpoint. And if you take a look at our route, basically this route is listening to this endpoint. So as soon as this message is pushed to this endpoint, our route picks up that message and then it sends it to the Kafka topic. So direct is a way you can connect different routes. That is one way, or mostly direct is something which is used for testing purposes. For our scenario here, you want some event, right? So basically you push something to this URI using this producer template. That is an event, and then this route will pick up that messages from that endpoint and then publish the message to the Kafka topic. So our route is from pickup from the direct colon push to topic, and then the destination is push that message to the Kafka topic. So now what I did is I have the Kafka consumer up and running, meaning the Kafka console consumer. So here our code iterates like 5 times, and then it pushed the message like, okay, let me change it. Hey, hello. It is going to be hey, hello 1 0 1 2 3 4 5. So what I'll do is I'll just run this and then let's see how it works. So the consumer is going to pick up the messages and then display it here. So now I'm running it. So if you take a look at it, it published the messages, right? It published all the messages to the topic, my topic. The way we are logging it here is by using this log processor. So this log processor takes care of logging the headers, whatever that are part of the message. And then if you take a look at our console consumer, so it pushed all the it pulled all the messages, hey, hello, 0 1 2 3 4 5. Now we have it up and running for 5 minutes. So I'm going to close this. What I'm going to do is I'm going to bring the consumer here up so that it is going to listen to the topic. So what we will do is, so it read all the messages. Now what we will do is we will go to the camel producer just for the sake of fun. We'll change this value to 50 and 51, 55. So it's going to post 5 messages, 6 messages, I believe, 50, 51, 52, 53, and 54, and 55. So all these messages will be read by this consumer as soon as I produce these messages. Now we have the consumer up and running. The consumer client that we created in the previous tutorial is up and running and then listening to the Kafka topic. So it's going to listen for 5 minutes, right? That's our setup here, meaning the setting here is to sleep for 5 minutes, meaning it is going to wait and listen to the topic for 5 minutes. Let's produce something here. Now this produces the messages. And if you go to the, where is the client? So let's check the console consumer picked it up or not. Yeah, console consumer picked it up. So now I have two console up and running. So let's go to this Kafka client. You see here, right? It picked up all the messages. Now we have both the Kafka consumer and producer up and running. As soon as you produce the messages and as soon as you produce the message using the Kafka producer, meaning the camel Kafka producer, the camel Kafka consumer is able to pick up those messages. Here we have the complete workflow working, meaning you push the messages using the camel Kafka producer and the camel Kafka consumer pull the message from the topic. So this is how in a typical real-time scenario what happens is there will be some other application which produces the messages, and then you will be having the consumer up and running, keep looking at the topic and then read the messages from it. So with this we have implemented both the Kafka producer and Kafka consumer using camel, and the scope of the tutorial is to code both Kafka producer and consumer using camel, and we have achieved that as part of this tutorial. What is Spark and Spark streaming? Apache Spark is a fast and general engine for large-scale data processing, and Spark is built using Scala, and Spark is 100 times faster than Hadoop MapReduce in memory, or 10 times faster on disk. I would like to give a little bit of background about how Spark came into existence. Hadoop was the most desired tool before Spark for big data processing. But in order to have a complete workflow with Hadoop, you need to have knowledge about multiple frameworks. Let's say you want to stream the data with Hadoop, then you can use Storm. If you want to query the data, then you can use Hive, and it goes on and on for different purposes. Spark came along with a generalized abstraction for big data computing by integrating different modules into one unit. Let's take a look at the different modules in Spark. Spark Core is the base of the whole project. It provides distributed task dispatching, scheduling, and basic I/O functionalities. Spark uses a specialized fundamental data structure known as RDD, which stands for Resilient Distributed Data Sets. We will discuss more about RDD in the next tutorial. Let's talk about the other modules. Spark SQL. Using this module, we can query the data. So unlike Hadoop, you can use Hive, or there are a lot of different modules that are available. Basically, those are not part of the same package in Hadoop. You need to add all those external dependencies on top of Hadoop. But with Spark, it comes along with the package. Next is a Spark Stream. This is a module used to pull the live streaming of data. We'll be using Spark Streaming module to integrate it with Kafka in the next tutorial. Next is MLlib. If you want to perform machine learning, then we can use the MLlib module. GraphX, that's for graph computations. So the scope for this particular tutorial is we'll be concentrating more on Spark streaming. And let's talk about Spark streaming in the next tutorial. So you can check more about Spark and the different capabilities of Spark in the below link. Let's talk about what is Spark streaming. Spark streaming is an extension of the core Spark API that enables scalable, high throughput, fault tolerant stream processing of live data streams. The input data can be coming from many sources such as Kafka, Flume, Twitter, and will be passed to the Spark engine to get the processed data out of it. Let's take a look at the flow diagram. Spark streaming component basically streams the data from the external source. Let's say in this case it is Kafka, and then the stream data will be sent to the Spark engine. Spark engine applies a lot of variety of algorithms and map reduce functionalities and create the process data. And the process data will be sent to different sources, will be fed to data dashboards, databases, and etc. So let's talk about who is using Spark streaming. Companies like Uber, Pinterest, Pandora, and Netflix, etc. They collect tons and tons of data real time and converts that unorganized data into an organized data for different kinds of analytics, such as recommendations based on users' activity, real-time threat analytics, fraud detection, Twitter usage of graph analysis for social usage, and they can forecast a lot of other things that can go right or wrong. So the most common use case of Kafka with Spark streaming is that consuming the data from the Kafka. Let's develop the Kafka consumer using Spark streaming in the next tutorial. Code the Kafka consumer using the Spark streaming module in Java. So here I have the Maven project created, and then let's start with adding the Spark streaming dependencies, and then we'll take it from there. So I have the code already available in the GitHub repo. Let's go and copy the dependencies from there. So I'm having some issues here. Okay, so in here, if you take a look at it, there are three dependencies basically. One is a Spark streaming dependency, and next is a Spark streaming Kafka dependency, and next is a Kafka clients. Why do we need the Kafka clients dependencies here? Because when it streams and pull the records, all the records will be pulled as a consumer record, and the consumer record is the one which is available in the Kafka clients library. Let's copy this and then put it in our Palmer XML. Okay, this is done. So once this part is done, basically right now we have all the dependencies. So let's explore that. So if you take a look at the Maven dependencies, as soon as you added this Spark streaming, it pulled all the transitive dependencies as part of it, and then added all these dependencies. So let's start coding the consumer part. I'm going to create a package called com.learn com.learn spark.kafka consumer. Then I'm going to create a class. So let's go and take a look at here. Here I have the class as Spark Kafka consumer. This is a class which I'm going to create. So let's write a main method. Okay, the next step is here we are creating a, this is the first step. The first step is to create the Spark context. There is a first step. Now here we have initialized the Spark context, because you need the Spark context in order to run any kind of Spark related operations. And next is here we are implementing in Java. So Spark streaming is supported in Scala, and in addition to Java, it is supported in Scala and Python. So basically, Scala is a preferred language. The reason being, it is built on top of Scala, but the API support for any other language that such as Java and Python, it is as good as Scala. So if you are developing in Java, there is no harm or there is no problem with that. The next thing is we are creating a Java streaming context. This is part of the, there are two things. I'll explain about duration in a minute. Spark streaming context is part of the Spark streaming API Java streaming context. It is part of that Spark package. So once that is done, it is the next step is the regular Kafka configuration. So whatever we have done before. So basically you have to pause all the servers to which you're gonna pull the data from, and then you have to provide the topic name. So this string deserializer and string serializer, all those are available in the Kafka clients package. That's one of the reasons we added the Kafka clients package. So here we are providing the topic name. Let's take a look at this. So here you have provided the against the bootstrap.servers property, you have provided the local host 1992, that is a broker against Kafka broker that is running in your machine, and then you're providing the group ID, and then you're giving the value as earliest, meaning start reading the value from the beginning, and you're setting the auto commit value as true. So here you're passing the topic name. So now we have all these values set up. We have to so if you take a look at this, I forgot to mention this. If we take a look at the streaming context, here we have here we're passing the Spark context as part of the streaming context. The next thing is, let's do it one by one. So I'm resolving all the compilation issues here. So now we have all the compilation issues resolved. So here is where you're actually creating the Kafka, the stream, so meaning stream to read the data from the Kafka topic. So the first thing that you're passing as an input, that is the Java streaming context. And next thing is the consumer strategies. So here you are providing the topic and the params that you are actually going to read the data from, meaning it has a topic and it has broker details. So once this is done, here we have the stream created. Once the stream is created, the next thing is to read the data from the stream. Yep, here we are using Lambda, so I'm going to change compilation unit to JRE 1.8. So in here you see you're streaming with for each RDD. RDD stands for Resilient Distributed Data Set. This is a basic abstraction in Spark, represents an immutable partition collection of elements. I'm just reading out from the documentation from that website. So represents the immutable partition collection of elements that can be operated on in parallel. This class contains the basic operations available in all RDDs such as map, filter, and persist. So we are not going to explore all the operations as part of the RDD. What we are going to do is for each and every iteration, it is going to give you an RDD object, and then we are going to just print the values that comes out of the RDD. Basically, you will be printing the record count and what is the actual value that we are posting from the actually that is read from the Kafka topic. So once this part is done, the next part is you have to start the streaming context. So let's do that. So the next step is to start the streaming context, and then we don't want to terminate it immediately. So basically, it waits for the termination to be called from the user or whoever is or by the program. So here we have the complete Spark Kafka consumer constructed, and it is ready. So let's summarize this. So basically, you're setting the app name, and you can give any name here. And after this, here I mentioned about, I'll explain you about the durations in a minute. So basically, what is the purpose of this duration is that go and pull the records every 10 seconds. That's what this definition means. So if you give the value as 1, basically it will go and pull the records from the Kafka topic every 1 second. So in order to have some clarity, I've just increased the interval from 1 to 10. So basically this value should be set based on your requirement. For example, if you have the processing is as soon as you read the message from the Kafka topic, if the processing takes more time, you can increase this value accordingly. So now we have everything set, and I have my Kafka broker and Zookeeper running in my local, and I have the Kafka console producer ready to publish the message into the topic. So the topic that I'm using is my topic. That's what I gave here. Yep. So let's start streaming it. You just have to run this program. So you might run into these kind of issues. There is a fix that is available for this. I will just show you that. So the fix is that basically you need to set the local host to your local port, meaning the local machine port. So basically you have to run this command. If you run this command, this will fix this issue. So what I'm going to do is I'm going to run this. Yeah, now we have set the host name and the port mapping. So once this is done, let me run the program again and then see how it looks like. So now you see here all the Kafka configurations, whatever we provided is configured, and then it started reading the value from the Kafka topic. So these are the values which are already available in the topic. So basically what happened here is this. Here we have the value set as earliest, so it is reading all the values from the beginning. Let's post something and then see how it works. I'm going to post hello. So it is going to pull every 10 seconds. So here it pulled the value from the Kafka topic. So you see these annoying loggers, right? Basically, you can disable this. The way we can disable it, so go to the resources and add the logger called log4j.properties. Properties. So now we have the log4j.properties. And then what you have to do is I'm going to go to the link and then go to the GitHub repo. So in the GitHub repo, I have the value set as log4j.properties. So the root category is info by default. That is the reason why you're getting all those info values. So you need to change that value to error so that it will not log all those info messages. Let's put this and then run it. You will not be seeing any of these things actually. So now if you take a look at it, it has a log4j dependency added when we added the Spark streaming library. Commons, common.logging. There is a logger dependency that gets added. I'm not able to find it now. Yeah. So when you place this log4j.properties in the path, basically takes all this. Yeah, here you see it. Log4j. I found it. So here it takes the log4j dependencies configurations from the resources class path, and then it overrides the default one. Let's run it now, and then we will see how the application behaves. Now you don't see any of those info loggings that happened before. Let's post something. Now it will be clear. How are you? Hello. We go to the broker. If you go to the consumer, basically it is going to pull every 10 seconds. Okay, let's wait until, yeah, now it pulled all the messages. So this is, now we have completed the Kafka streaming library with Spark. Basically, we have constructed the Kafka consumer, which uses Spark streaming to pull the records from the Kafka topic. In order to enable the delete feature, we need to make some changes in the server.properties file. So if we take a look at the server.properties file, we need to enable this delete.topic.enable flag equal to true. By default, this line of code will be commented when you download the Kafka distribution. Server.properties actually resides inside the config folder of the Kafka distribution. Now let's create the topic. So here, if you take a look at here, I have the zookeeper and the Kafka broker up and running. Here I have the create topic command available. So in here, I'm going to issue the create topic command. So now we have the topic created. Let's do a describe and then see how the topic looks like. As I mentioned earlier, I'm maintaining this GitHub repo for all the Kafka topic commands that I'm using as part of this tutorial. I'll be sharing you this towards the end of the tutorial. So here, if you take a look at it, this is a topic that we created, and this is a partition and leader and the replicas and the ISR. Now what we do is, let's call the delete command. So I have this delete command here. You see here, I have the delete attribute and followed by the zookeeper information. So in here, we need to give the topic name that we are going to delete. Okay, let's run this command. So it is saying the topic, my first topic, is marked for deletion. This will not have any impact if delete.topic.enable is not set to true. Meaning if we have this value set as false in the server properties, even if we issue the command, the topic will not get deleted. Let's double check and then see whether the topic is really deleted or not. I'm going to give the describe command against the zookeeper. See, it did not return any results. This confirms that topic got deleted. What is Spring Framework and why is it so popular? What are the different modules that Spring supports? And we will be concentrating more on the Spring Boot and implementation of Kafka modules using Spring is one of the most popular open source framework for developing enterprise applications. Spring is a lightweight framework. It was just started out with the inversion of control container. Spring was basically started to reduce the complexity and configuration of older Java enterprise applications. Spring was later evolved to build Java enterprise applications without EJBs. I would like to highlight this. What it means is that we can run enterprise applications without the need for application server. You might be wondering how can an application can run without the application server. Spring has its own container in which the Spring framework uses to run its application, which is nothing but the Spring container. Spring is POJO-based and interface-driven framework. POJO stands for plain old Java object. What this means is that you can even write the same code in Java without the Spring framework. Spring uses AOP and proxies to take care of the cross-cutting concerns such as transaction management and logging patterns using some simple configurations. Spring provides the creation of singleton and factory features as part of the framework itself. So if you want a singleton class for your project, so you can create these classes by plugging in a simple configuration. Don't worry, even if you did not understand what is Spring, you can still work on it and learn by hands-on. Let's check the Spring website and explore different modules that Spring supports. So I'm going to go to Google and then just type Spring Framework. So then I'm going to click on this link and then click on the projects. You see here, right, these are the different modules which Spring supports. I mean, they have variety of modules. For example, if you take a look at the Spring IO platform, which supports IO related modules, Spring Boot, this is a module which will be concentrating in this tutorial. Spring Boot is to create standalone production grade Spring based applications. Next is a Spring Framework, which has a core related features. Next is a Spring Cloud, which supports cloud related modules. Spring Data, which supports modules that interact with different kinds of databases. And Spring Batch, which supports batch related operations. Next is the Spring Security. This module can be used to enable security in your applications if you are running your application in Spring Framework. Spring 8 HTOs, that is for Spring based REST API development. Spring Mobile for mobile based development. And next, I mean, there are many other modules, and we will be concentrating more on Spring Kafka and Spring Boot. Spring Kafka provides Kafka abstractions in Spring. So in this tutorial, we will focus mainly on the Spring Kafka and Spring Boot. We will have hands-on session on how to implement Spring Kafka with Spring Boot in the upcoming tutorials. Using Spring Boot, we can develop standalone Spring applications. For example, let's say you are developing a web application. Before Spring Boot came into existence, the usual pattern is that project artifact will be a WAR file or EAR file, and you need an application server or a Tomcat container to deploy the artifact, and you can access the application using a URL and a port. But Spring Boot comes with embedded Tomcat and Jetty and Undertow server, and the artifact will always be a jar file. You just need to have Java installed in your machine to run any kind of Spring Boot app. Let's consider the previous example only. You need different modules for any enterprise application, such as a web module, transaction module, logging module, and if you have a database as a backend, then you need to add backend dependencies or libraries into your application to make this application a whole enterprise application. For any developer, it is always a tough task to manage these dependencies, and some versions might not be compatible with each other. You might run into some runtime issues because of this. But with Spring Boot, the framework takes care of building all the compatible version of different modules, and it is easy to manage the dependencies whenever you need to upgrade it to a different version. And it also auto configures the Spring environment for you. Spring Boot highly supports the configurations using Java, other type of configuration that are available in the previous versions of Spring, or the XML or annotation based configuration. On how to create a simple Spring Boot app and run it in your machine. Let me show you a quick peek on the app that we are going to build as part of this tutorial. So we will be building a REST API, and the endpoint is going to be /home. As you see here, http:/localhost is a local host in my machine. 88 is a port that it is going to expose the app, and /home is the endpoint. As soon as I hit this as soon as I hit this URL from the browser, it is going to give me an output, hello from Spring Boot. Okay, there are different approaches available to create a Spring Boot app, but I'll be showing you a demo on one of the approaches. So the prerequisites for this project is you need to have Java 8 installed in your machine, and I'm going to use IntelliJ, or I'll be using Eclipse as part of this tutorial, so you could use either IntelliJ or Eclipse. So I'm going to go to Google and then type Spring Starter IO. So I'm going to select this link. And this is a website from which we are going to generate the Spring Boot project. So I'm going to click on the switch to full version. Basically, it will give you many options in addition to this. So in here, what I'm going to do is I'm going to change the group ID to learn boot Kafka. And then the artifact ID also, I'm going to change it to learn boot Kafka. So what does it mean is basically when I build this project, the jar file that is going to generate will be learn boot Kafka.jar file. So if you take a look at here, the packaging is jar and the Java version is 1.8, and the language that I'm using is Java. I mean, you can build a Spring Boot project out of Groovy and Kotlin also. And below here, these are the modules which basically you can pick and choose what are all the modules that you need as part of this project. So there are a ton of modules that are available actually. As per the previous tutorials, I have shown you the different modules that Spring supports. So they have many modules here. But what we are concentrating as part of this tutorial is it's a Kafka and then simple REST API that we are going to develop as part of this simple Spring project. So I'm going to select Jax Oris, and I'm going to select Helios, and then I'm going to select the project called Kafka, the module called Kafka. So now we have 3 modules selected as part of this project itself, as part of the default Spring Boot starter project. So I'm going to click on the generate project here. So this will basically give me a zip file. So now you have the project, the Spring Boot project downloaded in your machine. Go here and then click on double click on this. So basically it gave me this project. So yeah, I would like to import this project in my Eclipse. So I have Eclipse open already. So in here, what I'm going to do is I'm going to import and import existing Maven project, right? So I'm going to import this existing Maven project. Click over here and then go to the downloads folder where we have extracted this zip file. Click on this one and then click open. So now we are importing the project that got generated from the Spring Starter IO website. I click finish. So you see here, basically it is importing the project, and it downloads ton of dependencies actually. That happens when we basically build the project. Let's explore the project first. So you see here it comes with source main Java, source main resources, and source test Java. Source main Java will be the class files that will be that will be available as part of the artifact. Source main resources where you can provide your properties file or some other templates or YAML file and stuff like that. So source test Java, this is where the test cases will reside. So in here, if you take a look at it, this is a main class. We call it in Spring Boot. There will be always a main class. This is a class which actually launches all the modules in Spring Boot. And you see this annotation right at Spring Boot on application. This is annotation which is responsible for launching all the Spring modules and loading the program into the Spring container. So you see here, this Spring Boot application has all these annotations built behind it actually. So if you go inside this, so there are ton of annotations actually which is encapsulated behind this one, and you see here there will be application or properties file. Okay, so this is how a basic Spring Boot app will look like. Now what we are going to do is we are going to add an endpoint. So in Spring, the way we can do it is, so inside this this main class is sitting inside this com.learn boot Kafka package. So what I'm going to do is I'm going to create a package called controller. Oh, I misspelled it. So let me rename it. Okay, let me put it inside this one. I want this to be inside the, okay, I believe it is already inside. So what I'm going to do is, okay, let me go to the navigator view. This view actually helps me a lot. So, okay, now this controller package is sitting inside the learn boot Kafka package. What I'm going to do is I'm going to create a Java class. It's a new other class. I'm going to give the class as home controller. I'll tell you the reason why I have given the class name ends with controller. So in order to expose an endpoint in Spring Boot, you can use an annotation called address controller. So basically all the packages are already comes along with a Spring Boot project, so you just have to import few things over there. And then I'm going to write a method public string get response. So this method is the one when you hit the HTTP localhost, our use case is like HTTP localhost 8080 and then home. As soon as I hit this endpoint, it is going to return me this message. So what I'm going to do is we are not doing anything fancy here. We are not integrating something like talking to a DB to pull the response and stuff like that. I'm just going to hard code it here. Hello from Spring Boot. So you need to use another annotation called @request mapping here. What it does is it maps the request, and then I believe I need to give this one. Okay, I'm going to import this. So the value will be, there is an attribute called value as part of this. Value will be /home. So now what we have told Spring is, okay, as soon as when you see a request like /home that is coming from any other external browser, or it could be any other client, just render that request and then return this response. So yep, what we'll do is we'll build the project first. Let's build the project by running the maven build command. There is a command called clean install. In the goals section, you have to mention clean install. Basically, this will build the project, and then the output will be a jar artifact. We can launch the jar artifact. The jar artifact is nothing but the Spring Boot application. So now the build is success, meaning it had successfully generated the jar file. Let me refresh this target folder. Now you see here there is a snapshot.jar file. This is a jar file which got generated by running the build. So what I'm going to do is I'm going to launch this java-jar target / and then learn boot Kafka snapshot.jar file. Okay, we'll launch this. So now the app is successfully launched. What we will do is we will go to the browser and hit this /home endpoint, and the response should be hello from Spring Boot. So I'm going to go to the browser and then hit this. Now you see here hello from Spring Boot. This is the response we are expecting, and as per the application response, yeah, it's matching. So now this endpoint is exposed, and we are able to access this endpoint in the 8080 port, and the browser is successfully able to communicate to the Spring Boot application. How does this wiring actually happens? So when you actually launch the Spring Boot app, Spring Boot has its embedded Tomcat built in it. Basically, when you launch a job, when you launch this Spring Boot application, basically the Tomcat is actually launched along with it, and then it exposed this application to the 8080 port, and then it is able to render the request whatever that browser is trying to access, and it is able to send the response appropriately. So here this is one of the handy feature of Spring Boot. Basically, if you do not have Spring Boot, you have to have a servlet container like a Tomcat, or you need to have the application server and a web server in order to respond to the request whatever that you are trying to access from the application. So now I do not want this message to be a part of the source code. I want this to be rendered, this to be pulled from a property file. So when you import the project, basically the project has a file called application.properties file. So in here, what I'm going to do is I'm going to I'm going to push this message. I'm just going to take this message from here, and then I'm going to read this message from the properties file. So there is a way, there is a class which comes handy with Spring Boot. So here what I'm going to do is I'm going to use the auto-wire annotation. So auto-wire annotation, basically what it does is it gives access to the beans whatever that is available in the Spring container. So when you launch the Spring Boot application, basically it creates an environmental class and then populates all the values that is available in the application or property file into this environment instance. So environment instance is something which stores all the values, key value pairs that are available in the application.properties. So in here, what I'm going to do is using this environment, I'm going to pull that value from there. So environment dot get property, it's like a system class or a property a configurator class. Basically you can get access all these by passing the key. When you pass the key, basically it will give the value of the appropriate key. So now I have made this change, right? So if you take a look at the response, it is just hello from Spring Boot. In order to see the difference, basically I added properties at the end of the message. So what I'll do is I will just shut down the app, and then I will build the project again. So I'll build the project by clicking this icon. So since you have built it already, you can rebuild it just by clicking this green icon. So now I'm gonna launch this project again. The response that I'm expecting now is hello from Spring Boot properties. Okay. See, now it is able to pull the message from the properties file and then send it as a response. If you take a look at it, wiring wise, we did not make much changes. Actually, the wiring happened automatically as soon as I got a hang of this object. It is able to read all the values whatever there in the application or properties. So let's discuss this scenario as a next scenario. In any typical application or any organization will have three environments: dev, stage, which is the non-prod, and another one is a production environment. Let us say in our example, we need to provide a different message for different environments. So basically, you will deploy this artifact in the dev region, and then you expect a response, and then you deploy the same app in the stage region, or that is nothing but the non-prod region, and the response should be different. And if you deploy the same thing, same application in the production environment, I need a different response. How can we achieve this? With this configuration setup here, it is not possible. With the code, with the level of coding we have, with the current code, it is not possible to achieve that. So we need something which should give us the response dynamically. So Spring Boot has a feature called profiles. It provides a way to segregate parts of your application configuration and make it available only in certain environments. To support this profile feature, we need to use a YAML file instead of a properties file. So by default, when the app comes up, either it looks for a properties file or a YAML file. So what I'm going to do is I'm going to create a YAML file. Application.YAML file. Ideally, you can either have a YAML file or a properties file. So what I'm going to do is, in order to avoid the confusion, I'm going to rename this file so that Spring is not going to pick this file as a default file. So now Spring is not going to consider this file. It is going to look for this file only. So in this scenario, what I'm going to do is we need some values to be populated here, right? So I have the code already available in the GitHub repo. So in here, I've created a YAML file. So I will share you this code as part of this tutorial. I'll link the source code to this tutorial. So in here, you see there are three dashes. This dash segregates each and every environment. So the first environment is dev, the next environment is stage, and the next environment is prod. So each environment have a different profile. Hello from dev for the dev region, hello from stage for the stage region, and hello from prod for the prod region. So basically, when you launch this command java-jar, now we are not passing any value. But if you want the profile to be set it as production environment, then we need to pass a value like -d spring.profiles.active equal to prod. I will show you a demo on that. Suppose in case if you do not pass any value, then in that case by default it will consider the region as a dev region. So let's build this project, and then we'll have a demo on this. So now I'm not going to pass any value. I'm going to launch the same java-jar command as I used in the previous section. So here the output that I'm expecting is, since we are not passing the profile, basically the output should be hello from dev Spring Boot properties. So in here I'm gonna go here, launch it. You see here by default it picked up the dev Spring Boot.properties. Now what I'm gonna do is I'm gonna change okay, so let me go here so that you can view the command whatever I'm typing clearly. So java-jar -d spring.profiles.active equal to, I'm going to give the value of stage, and then target. So this is the folder, I mean I'm in the folder where I have the project set up. So now I have launched the app. In here what will happen is the response that I'm expecting right now is basically it will go and pull the stage response from it. Okay, so I'm gonna go and then hit the endpoint. You see here the response that we are getting is stage. So with this app, so once you have the app built and up and running, what you can do is you don't even have to make any changes for each and every environment. So each and every environment have its own set of configurations, so that, for example, if you want to launch the app in the dev region, you will pass this -d spring.profile.active is equal to dev. If you want to launch the same app in the stage environment, which is nothing but a non-prod, then you will just pass this value. It is going to pick up the stage configuration setup for that. And for the production region, you just change this value to prod so that it will take up the prod configuration setup. So this feature comes handy with Spring Boot, and then with this it is easy to maintain the code base also. The code base is not going to be clumsy because we don't have to change the message for each and every environment and then deploy it with Spring Boot profiles feature. So we have to follow these 5 steps which is mentioned here. The first step is we need to add the Spring Kafka dependency in the pom.xml. Let's do that first. So I have the code already pushed to the GitHub repo. I will share you the code as part of this tutorial. So the Spring Kafka version that we are going to use is, we are going to use 1.1.1 release. Just copy this dependency and put it into the pom.xml. I'm using the same project that I've shown demo in the previous tutorial. So in the pom.xml, what I'm going to do is I'm just going to go to the pom.xml and add this dependency. So in here I have mentioned the version as 1.1.1 release. So now this dependency, what it does is basically it gives you the lot of Spring Kafka interaction related dependencies. Okay, let's take a look at the presentation and then see what is the next step. The next step is add the configuration details to the application.yaml file. Okay, so in here what we are going to do is we're going to go to the application.yaml file and then copy some configurations from there. Source, main, resources, application.yaml file. So in here we will just keep it simple. So we will just have only one profile populated with all the values. So in here what I'm going to do is let me open the application.yaml file here, and then I'm going to put everything below the dev profile. So in here what we are actually doing is we are giving the broker details, and then we are setting the auto commit to true and the auto commit interval to 100, and the group ID as group 1, and auto commit auto offset reset is earliest, and then the topic that we are going to read read the messages from is my topic. So now we have the application.yaml file setup, and the next one is the add consumer configuration using the @configuration annotation. Okay, what do you mean by @configuration annotation? I will just create the class and then I'll explain you the meaning of that in a moment. So in here, what we will do is we will create a folder called config. So go to other package dot config. So I'm going to go to the GitHub repo and then pull the code from here. So now, I don't know why my internet is very slow. Okay, I'm going to go to inside the config. So I'm going to create a class called Kafka config as mentioned here. Other class Kafka config. And then this class has annotation called @configuration. So if you remember from our previous tutorial, Spring Boot highly supports the Java configurations. So meaning defining all the beans and everything in the Java class itself. So prior to that, the previous Spring versions, they have used XML or annotation, and Spring Boot highly recommends the developers to use the @configuration, meaning define all your beans in the Java class itself. Now what we are going to do is we are going to do a bunch of copy paste. I will explain you the code line by line. So we have a bunch of compilation issues. Let's resolve those one by one. So it should be always Spring Framework. So it is complaining. Okay. Let's import the classes one by one. It is complaining this class is not available. Let's proceed further. Put consumer factory. Put default consumer factory. So there are a few compilation issues here. Import the hash map and import the consumer config. String deserializer. It should always be from the org.apache.kafka. I don't know why this class is complaining. Okay, now we are able to find that actual package where that class resides. And here, so we have to create one more class. Let's create a class. I'll explain you the purpose of this class. So create class in consumer. So here, okay, let's go through the code line by line. First one, I'm auto wiring the environment. The reason why I'm doing it, I want to read these configuration values inside this Kafka config file. Basically, here we are creating the consumer instance to read the messages from the topic. So Spring has two classes. Explain here. Spring so in Spring, basically you need to configure a message listener container and then provide a message listener. Let's talk about this message listener container. There are two message listener container. One is a concurrent Kafka listener container factory, which is a multi-threaded one, and next one is a Kafka message listener container, which is a single-threaded one. So a lot of other configuration information is available in the below link. Let me go to that link. Okay. So what I'm going to do is I'm going to go to this link. Okay. So if you go to this link, basically here we are now, this is a producer configuration, but we are in the consumer configuration. So here, when using a message listener container, you must provide a listener to receive the data. So this particular link has a lot of information, but I'm not going to explain the whole thing here. I'm just going to explain whatever that is required for this tutorial. So here we are using the concurrent message listener container. If you go below, I mean, you just read through it. It is really helpful. I highly recommend you guys to go through this one. So the first part is we are using the concurrent message listener. The concurrent message listener basically needs a container factory. It needs a consumer factory. The consumer factory class is nothing but the default Kafka consumer factory. And to this default Kafka consumer factory, we pass all the consumer configurations. So if you take a look at here, this is where we are setting the bootstrap servers, and this is where we are setting the enable auto commit, and all these values we set it here only. So you set the group ID and everything. And then this class is a tricky one. Basically, in this configuration, we are done with this part, and then done with this part also. Next one is at Kafka listener annotation. So I'm going to go to the GitHub and then pull the code, whatever that is there, and I'll explain you the code in a moment. So we created a class in the consumer package. The class name is consumer Kafka. So in here, so at Kafka listener is annotation, which Spring Kafka looks for this annotation, and then what it does is basically, if you remember from the previous tutorials, we do a poll, right? That's what happens behind the scenes when it looks for this at Kafka listener annotation. Basically, it polls and then gives a record one by one behind the scenes. So with this, we came to the end of the Kafka configuration setup. So these are the 5 steps that needs to be done, meaning these 5 list of configuration settings in order to have Spring Kafka consumer setup. Okay, now we have everything set. What we will do is we'll build the project, and then let me pull the zookeeper and broker up and running, right? So I can do to TKF1. So I'm gonna copy the commands from here. So the commands whatever I was using in the previous tutorials. This link is really handy whenever I want to run some commands. I just copy it from there. It's really helping me a lot. Okay, now we have I believe we have Zookeeper up and running. Okay, now after this, what I will do is I will bring the broker up and running. So okay, I need to go to the folder where I have the Kafka distribution. I believe this is gonna bring the app up without any issues. So it pulled all the configuration. Okay, now the broker is up and running. Now what I'll do is I will have the producer up and running so that I can produce some messages to it. TKF1. So the topic that I'm going to use is my topic. Let's see what are the different topics I have here. Oh, I need the shell script command. So in here, okay, it has a topic called my topic. And then what I'm going to do is I'm going to, so if you take a look at it, if you take a look at the application.yaml file here, we have the topic configured as my topic. And there is this wiring happens. How does the listener know this is a topic it needs to listen? So in consumer Kafka class, we have this at Kafka listener, and then in here we pass this value Kafka.topic. Basically, what happens is this Kafka topic pulls the value to which topic it needs to listen to from here. So Kafka topic is equal to my topic. So this Kafka Spring Kafka consumer is going to listen to this topic. So now what I'll do is I'll instantiate a producer and then start producing message to it. How can I instantiate a producer? There is a command here. So in here, I'm going to give my topic. So now we have instantiated it. I'm going to publish some messages. Hello Kafka consumer, hello Spring Kafka. how are you? So here, if you take a look at the consumer, what we are doing is we are just reading the record and then printing the record here. So let me build the project. So in here, I'm not passing any profile. So by default, it is going to take the dev profile and then have this configuration setup, the Kafka consumer setup for this particular configuration. See, it read the messages, hello Spring Kafka and how are you? Let me publish some messages. Are you up? Say hi to Spring. If you take a look at it, it is able to it is able to pull all the messages. So here we are pushing the messages from the producer. Here it is pulling the message from the topic. Basically, the Kafka consumer using Spring is up and running, and it is listening to the topic and pulling the message from it. So for example, obviously for the other environments, for the stage environment, the server will be different. For example, let's say it will have some value like 10.12.34.45. So this is a broker server, and this might be the port. And for prod, it could be different. So with this, what we can do is it could be 723 or something like that. So here you will configure all your brokers like this, and then the topic name also could be different. I mean, ideally it should not be. If the name is different, each and every environment, let us say each and every environment have a different name. So in that case, you can configure that also. And the beauty here is you don't even have to make any changes to the app. You just have to change when you are launching the application, you just have to pass the profile to the appropriate environment so that it can pull the appropriate configurations. For example, if I give the value as my topic 1, and then when you launch this same project, meaning same Spring Boot project with the profile value set as stage, this consumer Kafka is going to listen to a topic called my topic 1, not my topic, which is set in dev region. So this is one of the very nice feature of Kafka, which I love it. And have a hands-on session on Spring Kafka producer and its setup. So here, like how we did for the Spring Kafka consumer, there are some set of classes which we have to instantiate in the configuration class, meaning we have to create some beans. One of the bean that we need to create is a Kafka template class, and next one is a producer factory class. Let's take a look at let's actually code and then see how it looks like. So in here, open the config. We are going to use the same config file. So in here, this marks the end of the Kafka consumer configuration. Let's start the producer configuration from here. So I'm going to pull the code from the GitHub. So if I go here, then I'm going to go to the config folder. So here we have the code that are required for the Spring Kafka consumer setup. So in here, I want to import the producer factory class. So if you take a look at here we have used the default Kafka consumer factory. Similar way, we have another class in the producer, and that is a default Kafka producer factory. We're gonna import this package. So now we have imported everything. So and here, similar to the Spring Kafka consumer, we have a producer consumer config, producer config class, and then so here we have added the string deserializer and string deserializer because this one is a consumer. Now we have Spring, it's a producer, right? Now then in that case we need to have the string serializer imported over there. It should be always arg.apache.kafka. Now we have this setup done. Basically, let me go to the presentation again. So if you take a look at here, Kafka template.send method, this actually connects to the topic and returns a listenable future object. So let's code this part. So for the purposes For the purposes of this, what I'm going to do is I'm going to create a package called producer package. Called producer, and then in the producer I'm gonna create a class, copy, I have the code already available here. I'm gonna pull the code from here. The class name is producer Kafka. So, and then I'm gonna copy a bunch of code. So in here it gives me a lot of compilation issues. Okay, so it is complaining create a class and result. I don't know why does it complain like that. Okay, sometimes it goes crazy. So what I'm gonna do is I'm gonna put the send result for the listener feature callback. Put listenable feature. Oh, what's happening? I'm importing it, it's not importing properly. So what I'm going to do is I have all the inputs here. I'm just going to copy and paste it over there just to save some time. Okay, all the compilation issues are resolved. This is good. Now we are calling this. So if you take a look at here, we are auto wiring this. So what will happen here after you auto wire it? So when the Spring Boot app comes up, basically it will create all the beans that are defined in the configuration annotation. So I forgot to tell you this. So what happens is when the app comes up, it first loads this class, and then the next step is it will load all the classes which has that configuration annotation, and then it loads the add component annotation. So it follows that pattern basically. So when this application comes up, it reads this configuration annotation, and then it creates all the beans whatever that is defined here. Now at Kafka template is created, and then here uh, we have to annotate this one with at component. So this will also be considered as a Spring Bean, and then at Kafka template is auto wired. So whatever the configuration that got created in the Spring container will get the access for this Kafka template. So basically using this Kafka template class, and then you'll call the send method, and then you see here, right, we are getting the property called Kafka.topic. This basically returns you the actual topic that you are going to connect to. So this is where the producer and to which topic this particular producer needs to talk to and publish the message. The wiring happens here, and I believe I explained the configuration setup for the Kafka. So here, Kafka producer. So here we define the broker and the serializers and all those generalized configuration. And then here is where we mention the topic needs to connect to. In the configuration, we mentioned the broker. Here we mentioned the actual topic. I want to make the code a little change to the controller part. So here, what I'm going to do is instead of just publishing the message, meaning the wiring. So right now we have the code here, right? Someone have to call this method in order to actually push some messages to the topic. So who will call this message? So there needs to be event. That event should trigger this message, right? So it should trigger this method. So what we do is we'll make a little change to the home controller. So what we can do is we will instantiate this producer Kafka using the auto wire. Basically we get the access for that particular object. Sorry, at auto wire producer Kafka, producer Kafka. So now we have we got the AutoWire functionality done here. Basically, this we have this one defined as that component, which eventually means that this will also be a bean in the Spring container. You can access a bean in some other class using that AutoWire annotation. So now we got the instance of that. Now what we'll do is we will call the send message method. So for this method, we need to pass some value, right? So what we will do is when we hit this endpoint, basically we will push something to this particular method. So the way what we are going to do is the use cases, the user is going to send some message from the browser, and that message is going to get published to the topic, and the consumer is going to read the message from the topic and then just display it. So I have the code already available for that. In here, what we have to do is we have to just add this at request param. What this annotation does is basically it pulls a value whatever the browser is going to send, whatever this browser is going to send, meaning browser, let us say that is a user who is sending some message, that is an event. That event triggers the producer, which will eventually push the message into the topic by after this call. Once this call is done, we are getting a callback. This callback on success will just print the success. On exception, it will print the exception value. Okay, so in the client, meaning in the browser, what we need to do is we need to pass a value called input, and then meaning this is going to be a request parameter. Okay, now we have everything set. Let's stop this consumer, run it. I'm going to build it. So this consumer has a producer and it has a consumer. What is going to happen is when the user sends some message, sends some value against this input parameter, that message is going to get posted into the Kafka topic, and the consumer, which is built along with the app, is going to read the message from it and then display it in the console. Okay, I have the app up and running, and now what I'm going to do is from the browser, so the way we can pass the value is like this, question mark, and then pass the request parameter, input equal to hello from browser. So if you take a look at the code, in the code we are expecting that parameter, and then we just pass the value to our producer, and producer will call the send method. This send method, eventually it's like a Kafka producer dot send method, which actually connects to the topic and put the message into the topic. And the consumer, which is already a part of this project, is listening to the same topic, and then it is going to read the record and then print it in the console. This is a whole workflow. We have implemented the whole workflow here. This is really good. Okay, let's run it. So I have pushed the messages. I have published the message hello from browser. So let's take a look at the, you see here, inside success, meaning in the producer Kafka, if the message is successfully sent on success, we are just printing this. This read record is actually from the consumer. So now we have a complete workflow. There is an external event basically that triggers a producer to publish a message into the topic, and there is a consumer which is listening to the topic, which read the message and then printed it over here. This is a whole workflow. We have covered the complete workflow here in Kafka. Let's publish some more messages and then test. Hello from browser 2. Hello from browser 3. So this means the reason why you are getting this message is, so after that publish is done, basically, so in here, basically you are returning something back to the client. So you see here, hello from browser 2 and hello from browser 3. On how to manually manage the offset in Spring Boot. Why do we have to manually manage the offset in the first place? Quick recap from our previous tutorials. In any real-time scenario, what normally happens after the message is consumed from the Kafka topic is that it runs a bunch of validations against the message, And once the validations are successful, then the message might be sent to either some downstream systems, or the attributes of the message can be persisted in some data store. If we have the enable.auto.commit value set as true, then offset might be committed behind the scenes before even the business validations are completed in the Kafka consumer end. Managing the offset manually is the safest and the recommended approach to run your consumer in production environment. This gives a lot of control in managing the offset, and it should be always the application that holds the responsibility of managing the offset. Let's code this in our Spring Boot app. Before we code it, I would like to give you the list of files that we need to change. The first change is in the application.yaml file, we need to change a value to value of enable.auto.commit to false. That's the first change. And the next change is in the Kafka configuration, when we constructed that concurrent Kafka message listener, we need to explicitly mention the value as manual. By default, it is set as batch, so it commits the offset behind the scenes in batch. And next one is we have a class called acknowledging message listener. We have an interface called acknowledging message listener. The class which has the @Kafka listener annotation mentioned needs to implement this interface. Let's take a look at the code. So here, this is a code where we left off in the previous tutorial. For the purpose of saving some time, I have actually pushed the code into the GitHub repo. So there is a new project called learn boot Kafka -manual -offset. If we go inside this project, let's go to the application.yaml file first and then see what is the change that we need to make. So if you take a look at here the value set as false. Let's go and change this value in our code base. So this value, let us change it in the dev profile only. This value should be false. This is the first change. And what is the next change that we need to do? So after this, we have to go to the Kafka config class. Here, if you take a look at it, we have a basic Kafka listener container factory here. So we need to modify this. So we need to modify the Kafka consumer config value to something like this. So go to the config folder. In the config folder, here we have something like manual. We're going to do the same. So if you remember, I have added one more attribute called set poll timeout. If you remember from the previous tutorials, there is a poll command in the Kafka consumer. We normally provide some milliseconds in that one. So this line is for the similar purpose. We are asking the Kafka consumer to connect to the topic and poll for 3 seconds, and then pull all the records, whatever it can in that 3 seconds. So in here, I'm going to add those two things. So I'm going to import this. It's complaining. What I'm going to do is I'm just going to copy this from here. Okay, the compilation issue is gone. So this is the second setup that we need to do. And after this, what we have to do is we need to go to the class which has the @Kafka listener annotation in it. That class is this one. So in this one, let's see what is the code change that we need to do. Go to the consumer Kafka. It implements the interface, right? Let's copy this interface. So here it is, we need to implement this interface. So basically this interface have a method that we need to implement it here. So and then what I'm going to do is, this is a method which we have implemented just now. What I'm going to do is I'm going to copy this and then put it here. And then I'm going to delete this. Okay, before I delete this, I would like to show the difference. If you take a look at here it has two parameters, meaning two arguments. One is the acknowledgement object and another one is a consumer record. Consumer record is a record which will actually have the actual payload, meaning the actual message it read from the Kafka topic. Using the acknowledgement object only, we are going to commit the offset back to the Kafka topic. So basically what happens is in without Spring, we have a method called commit sync or commit async. We normally we can manually manage the offset and we can commit the offset using those methods. Behind the scenes, when you call, so there is a method called acknowledge. So this is a call which actually commits the offset. Behind the scenes, it calls the commit async or commit sync. And then what I'm going to do is I'm going to copy a few other code from here. So I'm having a try catch. So here you go. So in the consumer record, basically it has a lot of other attributes, but I'm just going to specifically point out few things. So the value which gives the actual payload, and offset which will give you the actual offset value of that message. Topic gives you the which is the actual topic from which it is reading the message. Partition, it tells you the which partition this message is being pulled from. And then we are committing this offset in the final block. The reason being, irrespective of any error scenario or anything, we are going to commit the offset back to the consumer. But if you take a look at here we are actually completing our processing of the message, whether the message is persisted into the DB. You might have a DB code here which will actually call the DB and insert the data, or you might have some downstream system call, like you can push this message to another Kafka topic or another API call or something like that. Once that is done, and then you'll do the offset commit. But if there are any issues in these scenarios, even in that case, you have the control to what to do further. For example, if you want to push this message or reprocess it, you can do that, or you can actually call the commit the offset towards the end of it. Let's run this and then see how it behaves. So I'm building the project. Okay, it's built. So now what we will do is we will launch the job. Now the job is up. If you take a look at here, in our previous examples where we did not use Spring, where we were using conventional Java, normally it does not tell you what are the list of partitions this particular consumer is listening to. I mean, I did show examples where we read the message. From the message we get the offset partition and then print the partition. That is one way of knowing from where this partition actually comes from, but there was no way to determine what are the list of partitions this particular consumer is listening to. But using Spring Boot, meaning Spring Kafka, it can tell you what are the list of partitions it is listening to. So my topic is a simple topic which is having only one partition, and it is listening to that partition. So I'm going to go to the browser and then post some message from here. Localhost home. If you remember from the previous tutorials, we have something called home hello from browser. As soon as I print this, basically this is a response message that we get from our REST API call. So if you go here, you see the method it prints the message, whatever that is posted from the browser, and then it tells you what is the offset value of that message, what is the topic it is listening to, and what is the partition. And this is very handy in Spring. Basically, you can manage the offset in the Kafka consumer, and it is a recommended approach in any kind of environment, particularly in production environment. On how to achieve consumer group logic using Spring Boot. Quick recap from the previous tutorials. Using consumer group, we can scale and achieve faster throughput by reading the messages from different partitions at the same time. To achieve consumer group, we need to have multiple instances of the consumer with the same group ID. I will show you how to run multiple instances of the Spring Boot app in your machine. For the purposes of this tutorial, I have altered the topic to have 4 partitions. I'm in the location where I have the project set up, and I'm going to launch the project as like we did in the previous tutorials. jar target. Now one of the Spring Boot instances up and running, and it is listening to all these partitions: my topic 0, my topic 1, my topic 2, and my topic 3. What I'm going to do is I'm going to launch another instance. I'm not going to change anything to the previous command. I'm going to launch it with the same command that we used in the previous for the previous instance, and then I'm going to see how the application, how it is going to behave actually. So now we ran into an error. What is this error? Application failed to start. The Tomcat connector configured to listen on port 8080 failed to start. The port may be already in use, or the connector may be misconfigured. So what it is saying is, when we launch the first instance, basically it uses a Tomcat container, and Tomcat by default it uses the 8080 port. So here we did not provide any specific port value, and it is trying to connect to the same port, but it is already in use. So how can we override this default value and make the Tomcat to listen to a different port value? So there is a way we can achieve that and have it mentioned in the GitHub repo itself. So if you take a look at here, we can pass a parameter called -d server.port equal to 8081, so that Tomcat will consider this port value and then launches its instance. So here what I'm going to do is, port equal to 8081, and then so here, as soon as this consumer came up, the group coordinator, there will be a request into the group coordinator with this group ID. And group coordinator, what it does is basically it checks, is there any other consumer with the same group ID that is up and running? And then it determines this, there is a group, there is a consumer with the same group ID, and it is using all these partitions, 4 partitions. And then what it does is it rebalances the partitions, meaning it distributes the partitions to the another consumer, and then if you take a look at the current partition assignments, this instance is listening to my topic partition 0 and partition 1, and this topic, this consumer is listening to partition 2 and partition 3. What I'll do is I'll try to post some messages and then see how the messages are distributed here. So here I'm posting the messages one by one. You might be receiving like thousands and thousands of messages in a second. So in that case, both these consumers will distribute the load and process a message parallelly, meaning the throughput is going to be really high. In here, I'm going to take this value. So here, this message is read by this particular topic. I'm going to post one more message. I'm going to post another one. I'm going to post another one. I believe the consumer, we have a logic to place the messages only to the partition 0 or 1 by default in our producer, and that is the reason why it is actually pushing all the messages into either one of these topics, and this consumer is reading from it. But in real-time production environments, the messages will be published to all the partitions, and these two consumers will read the messages from all the partitions parallelly. Talk about what is Docker, why Docker, and what is a container. Let's start with why Docker. Everyone is talking about containers and Docker nowadays, and the companies are adapting to Docker at a remarkable rate. Before containers and Docker came into picture, all the applications are deployed and run on physical servers. The workflow is, whenever a new application is developed, then the next steps will be to create the servers to deploy the app in those servers. When I say servers, create an application server on top of a server. In any enterprise today, you have a develop, test, which is like a non-prod, and a production environment. Then the server needs to be created for all those environments. There is a significant amount of work over there. And then in addition to the significant amount of work, there is a significant amount of cost and maintenance involved in this approach. Before we jump into Docker, let's discuss about containers first, because containers and Docker go in hand. Let's talk about containers. What is a container? A container consists of a runtime environment, an application, and its dependencies, and libraries, and other configuration files. All these are bundled into one single package. With this, we can run the same container in any environment. We don't need any server setup specific for that application in different environments, such as test, develop, and production. Let's see how containers fit into this world using a simple diagram. So you see here, containers share the same operating system, and it carves out a part of the OS resources and mounts it into the container. So basically, you need a server and there is an operating system on top of it, and you can create n number of containers on top of these operating systems, meaning each and every container will take a little bit of the system resources and then mount it into the container, and the application will use those resources to run the application. Let's talk about the advantages of containers. Since it takes a little amount of the resources that are available out there, they are lightweight and they are incredibly fast. It consumes very less system resources. Eventually, we can run many apps into a single server, meaning there is going to be a lot of cost saving for any enterprise. Let's talk about Docker. What is Docker? Docker is an open source platform, and it consists of a Docker runtime, which is a Docker engine, and next one is a Docker Hub, a service for sharing the applications into the cloud. This is similar to GitHub. Basically, what Docker creates is a Docker image, which will have the application code, and let's say this is a Java app. Then it will have the installation of the Java environment and other libraries that are required for the app. The Docker image is created using the Docker file. In order to build or run Docker, you need to have a Docker installed in your machine. Once the Docker image is ready, you can push it into the Docker Hub, which is similar to GitHub. Once the image is pushed to Docker Hub, it can be pulled from there. When the Docker image is run, then it runs as a container. Let's take a look at the architecture, how it looks like with the addition of Docker. So basically, you need to have a Docker installed on the machine, and you will have Docker images created using this Docker software. And the Docker images, when you run the Docker images, basically it creates a container out of it. Let's see what are all the advantages of Docker. Rapid application development. Since the application environment setup is minimal, deployment of the app will be really faster. Easily sharing the artifacts. Docker images can be shared easily using the Docker Hub, and these are faster and lightweight. Docker images are really small, which are really faster and easy to deploy. The startup time of these Docker containers are faster compared to the traditional monolithic apps. Show you a quick demo on how to install Docker Toolbox for Mac. So I have an older version of older version of the Mac. So I'm using the Docker tool. I'm installing the Docker Toolbox. If you have a latest version of the Mac, meaning, so let's go to this link and then check the system requirements for installing the latest version of Docker. So a Docker Toolbox provides a way to use Docker on older Macs. This is an option which I'm going to choose. Let's see what are the system requirements for for the newer version of Docker. So if you take a look at here, if you have OS X E1 Captain, and it must be Mac must be 2010 or newer model. If you satisfy all these criteria, then you can install this version, meaning the installation is pretty straightforward compared to any other versions of Docker. Even the installation steps are clearly mentioned here for Ubuntu, for Windows. For example, in case of Ubuntu, you just go here and then Google Docker Toolbox for Ubuntu. So the steps are pretty straightforward and it is clearly given here. You just have to follow the steps whatever that are listed here. For the purposes of saving some time, I have downloaded the Docker Toolbox already. So let's start the installation process. So here is the Docker Toolbox. I'm going to click continue. I'm going to click continue here. Yep. And after that, here you will be adding those to the tool that to get started with Docker. So we need both of those. Kitematic is a UI version to manage the Docker. Terminal, it's like any other terminal that we have in our Mac by default. So it is recommended to always use the Docker provided terminal if you are going to perform Docker related operations. So the installation is successful. I'm going to just keep it. So now you will see the Docker Quick Start terminal. So when you bring the app, meaning when you open this terminal for the very first time, it does a lot of background process, and then it creates a Docker machine, Docker Compose, and all those stuff. So it does install VirtualBox also as part of the package. So let it run in the background. Let us go through this documentation. So now we got this Get Docker Toolbox for Mac, and then so these are the steps. I mean, the screenshots, whatever they have provided here, it's awesome. It's straightforward. You just have to follow whatever the screenshots that are given here. So once this installation is successful, basically to run your container, you create a new Docker engine host running. So use Docker to create use Docker client to create, load, and manage containers. What we are gonna do is we are going to launch this one. I believe that's what we did. So yeah, the process is still running in the background. So once the process is complete, basically you will see this image, meaning all these things. So it has to generate the VirtualBox, it has to generate the SSH key and VM and all those stuff. It sets up the environmental variable for machine develop. Once this is done, basically you can run a Docker version, and that will display. So you see here, right, it downloaded something from the GitHub, the boot to Docker ISO, and right now it is creating the machine, it is creating the VirtualBox, it is creating the SSH key. So if you take a look at these steps, whatever that is given here, it is the same. So and then once this is done, it will start the VirtualBox, and then it will start the VM, and then make this Docker client connect to that. So right now it is waiting for an IP. So now it is setting up the Docker. Okay, Docker is successfully installed in the machine. So if you do a Docker -version, it will give you the version. I don't think I have to. I can give Docker version. Yeah. So now you see that Docker is successfully installed in your machine. So the process is the same for Windows, and how to install Docker Toolbox on Windows 10. So you have to go to Google and then just type Docker Toolbox for Windows 10. So and then click on this link here, install Docker Toolbox on Windows. So I'm going to open that link. So in this link, you will see the steps that you need to follow in order to install this in your machine. So the steps are pretty straightforward. Click on the Get Docker Toolbox for Windows. So it will give you, it will start downloading installation for you. So for the purpose of saving some time, I have downloaded this Docker Toolbox already. So I'm going to go to the location where I have copied this Docker Toolbox. So what we are going to do here is we are going to install this application. I'm using Windows 10 home version, so I have to, that's an older version of the Windows. So in that case you need to use Docker Toolbox. If you have some advanced version of Windows 10, then in that case you can use the Docker for Windows. Let's click this one. The installation is pretty straightforward, like any other installation. Just click yes, and then it will ask you to install. Yep. And then these are the things that we are going to install: Docker client for Windows, Docker machine for Windows, Docker compose for Windows, VirtualBox, and Kitematic. Kitematic is UI GUI for Docker. So the installation is going to take some time. Okay, the installation is complete. Now what we will do is we will click on the finish button. So now if you take a look at the Windows here, if you take a look at if you click on the Windows button, you will be seeing all these three things which got installed: Kitematic, Docker Quick Start Terminal, and the Oracle VM VirtualBox. Let's click on the Docker Quick Start Terminal. So it is going to download a few things. So basically, when you actually open it, it will do some pre-create checks. It will create the Docker machine in your local, and then it will create the SSH key. It will create the VirtualBox when you open the Docker Quick Start Terminal for the very first time. So you might be facing some issues. The issues like how to enable. Yep, you need to click OK for this. Yes for this. How to enable VT. So sometimes what happens is when you pull up the Docker terminal, it might tell you like this is not enabled. The virtualization is not enabled in your machine. So basically, you just have to follow a few steps, and I'll share you the link. So if you follow this link, basically how to enable Intel VTX on Windows 10, it will explain you how you have to go to the BIOS settings and then enable the virtualization for it. Let's open the Docker terminal. So right now it is in the last state of creating an IP for this Docker Quick Start terminal. Once this is done, it will tell you, okay, the Docker is successfully installed in your machine. So if you open this link, basically this video will clearly explain how to enable the Intel VTX on Windows 10. Because when I installed it for the very first time, I had run through this issue. Docker was not starting as expected, so I followed this video, and then this video does not have a really good quality, but it does the job for you, meaning you can enable the virtualization in your machine. Let's see where are we with the Docker terminal. So it is waiting for an IP still. So it is saying the host adapter is corrupted. Let's go stop the VM, fix the host only adapter, and restart the VM. And I did not have this issue when I installed this for the very first time. So now it is copying the certs to the remote machine, setting up the Docker. Okay, I believe it is going to get completed. Okay, when you see the screen, meaning the Docker installation is completed in your machine. So now what you can do is you can just do Docker version. Okay, Docker is, let's do this, and I can help. Okay, I'm just running this in git bash. So let's see what are all the next steps after you successfully install this. Check your version. This is not the step we are looking for. So we are right now in this step. So what we can do is we can docker-machine ls, we can do that. -machine ls. So you see here a default, this is a machine that is installed in your machine. Docker-version, I believe this is a command. Docker. So you see here, right, the Docker version is, it is saying the client version is 17.031CE and 17, the server is 17.04. So with this, what it explains us is like the Docker is successfully installed in your machine. So my idea is to connect to the Docker hub and pull some Docker images and run the Docker image in the Windows machine. This is planned for the future tutorial. With this, we came to the end of the installation of Docker toolbox in Windows. We have our Docker installed in our machine now. Now it's time to build the Docker image using Docker. As I mentioned in the previous tutorials, I'm using Mac for this demo. So we will build the Docker image out of the Spring Boot app that we developed in the previous tutorial. So you need a Docker file basically to build a Docker image. And there are some additional changes that we are going to do as part of to the current project that we developed as part of the previous tutorial. Now, the first thing is we have to include a Docker Maven plugin in the pom.xml. So if we go to the project, basically, so I have this code already pushed to the GitHub repo. So if you take a look at the GitHub repo, you will be seeing a project called learn boot Kafka manual offset -docker. So the first change is go to the pom.xml, and then in the pom.xml you see here, right, the plugin called Docker Maven plugin. So this is a plugin which I have added. So let me show it in the Eclipse workspace. So in the pom.xml, the plugin that we are using is com.spotify. This is one of our friend. He contributed a lot to the Docker community. So we are using the plugin that he developed. So meaning, I don't know whether it's a he or a company that does this. So this Docker Maven plugin that is required in order to build the Docker image out of the project. So the first step is to make this change in your pom.xml file. So include this whole plugin. And what it does is basically it will create an image with the image prefix name. So image prefix name, what we have given here is the image prefix name is the lib. I will explain you why I gave this name. And then the next is the project artifact ID. The project artifact ID is Docker manual offset. And then there is a Docker source directory. So this directory points to source main Docker. I will explain you why did we give this value here in a moment. So the next one is that what is the target path, and what are the resources that it needs to include. So let's get into the presentation. So right now we are done with this part. So this is a change which we need to make in the format XML. The next step is to add two files in the source main Docker. So here, if you take a look at it, we have mentioned a path called source main Docker. What are the two files that we need to add? One is the Docker file. Docker file is where the whole process will start. The whole Docker image process will start. I'll get into the details of that one in a moment. The next one is a docker entry point.sh. So this is an optional file. You don't need it sometimes, but I have given it here for a purpose. I will explain you the purpose in a moment. So the next one is we need these two files. Let's get into that file and then see what are the contents that are available in these files. So if we take a look at the source main, the Docker is a folder that we need to go and take a look at. So all these code is available in the GitHub repo. So suppose in case if you do not want to develop, you just want to take a look at the code directly, then pull this repo and then import this project into your workspace. So this is a file which I'm talking about. So here, let's open that Docker file. So this is a Docker file. It has like a bunch of commands, meaning the bunch of arguments that you need to provide. So I would like to explain what is a Docker file, as per the documentation from the website. So as per the documentation from Docker website, each Docker file is a script composed of various commands and arguments. So if you take a look at it, that's what it is. It is a list of arguments and a list of commands listed successively to automatically perform actions on a base image in order to create a new one. So basically, it performs all those actions as per the instructions that you provided, and then it will create the Docker image out of it. Okay, what is a Docker file? Let's explore what each and every value is. So the first, it starts with a from. So always all the Docker images, it starts with a from. That is one of the most crucial one compared to the others. And from should be the first command in any Docker file. Okay, so it pulls the image from the Docker hub. In this example, what it does is here it pulls the Java image from Java image Alpine-Oracle JDK 8 :slim. This is the image. Basically it is pulling it from the Docker hub, but this is the user who have uploaded that. So I will explain you how to create an account in Docker hub and how to push and how to pull images from the Docker hub in a moment. What is the next step? The next step is you're assigning a volume. This is an optional step. Basically what volume does is, volume command is used to enable access from your container to a directory on the host machine. For example, you have Docker running in your host machine. You want to access a directory in your host machine from the Docker container. So in that case, if you give something like this, what will happen is the Docker container will be having an access to talk to the directory /temp in your host machine. If you don't give this, then you will not be having any access. The next thing, what is a add command does? So what does add does is add command takes two arguments. One is a source and destination. So here you are actually copying this jar file as an app.jar file to the Docker image that you are creating. Okay. The next one is the expose. So you are exposing these ports out of the Docker container. And next one is you are copying a file, copy command. Copy command basically takes two arguments. It copies this file from your local machine, that is this file, and then puts it into the Docker image. This is done. And next one is the entry point. Entry point, what it does is, entry point is something which sets the concrete default application that should be used every time a container is created using the image. Oftentimes entry point is used in conjunction with command. So basically what it does is, you gave this command a start, right? And entry point is docker-entry point.sh. So when you actually run this image, what happens is it basically executes this file, the docker entry point.sh, and then it takes the command start. So that is what you are passing. So you'll be here, you'll be passing the command as start, and then as soon as that command, the first argument that is passed to this file is start, then it will start executing the script actually. So what is happening in the script? Let's talk about this at this moment. So here they're validating if the environment is the environment variable is passed as part of the docker run command or not. Okay, that is the first step. So if it is not passed, then it will error out stating, okay, please pass a environmental variable. The next thing is you have to pass this variable, the Java security -d Java security variable. And then next one is that, okay, once we have passed the environment, we are appending it into our Java launch command. So basically what we are doing is, so if you remember from the previous tutorial, we have launched our Spring Boot app using the java-jar command. And then here we are java-jar, and then we passed bunch of -d options. Here also we are doing the same thing. So, but what we are doing is we are basically constructing this, all the system arguments using this script. So first thing is you will pass the environment as stage or prod. I mean, the idea is to use the same container in all the other environments, right? So if you pass stage, then the stage level configurations will be pulled. So if you remember from our previous tutorial, we have a file called application.yaml. So if you pass the profile value as dev, then it will pull the dev related configurations for that running application. If you pull the if you push the, I mean, if you set the value as stage, then it will pull the stage level configurations. If you pass the environment as prod, it will pull the prod level configurations. So the idea is to use the same container but modify the environment based on the value that you pass, meaning connect to a different environment based on the value that you pass. So with this, if you remember from the traditional application point of view, basically you need to create an application server, and then you have to set up all those environmental variables and all those stuff. You can totally avoid all those steps as part of this step. Okay, so at the end of this script, what it does is it does execute java-jar command. So this is like, okay, launch the application. Once all these validations are done, once this Java options, meaning the complete system level variables are set, then launch the application. That's what it does. So there are few commands that we need to know in order to build the image, or in order to run the image, whatever we have built. So I have a GitHub repo, meaning I have it included in the same repo. So if you take a look at it, I have a Docker commands file. So the first command, how do you build a Docker command, Docker image, right? So that's the first step. Copy this, and then right click this project. So I mean, as part of the changes related to Docker, one thing is the Palmer XML. The next two changes are Docker file and Docker entry point.sh. So once these are included, right click this project, and then click on run as, click on Maven build, and then copy that goal, meaning whatever we copied from the GitHub repo. So the goal is Docker build. So if you run it, so basically what it is going to do is, so it is building the image. You see all those steps, right? So it will follow whatever be the steps that we mentioned in the Docker file. So here the Docker file, the first step what it did was it pulled the images. So here I have run this project already multiple times. So I have all those images already available. If you are doing it for the first time, basically what will happen is it will pull all those images from the Docker hub, and then it might take more time than usual. So the first step is this, and then it is mounting the volume and then adding that jar file, whatever we have developed, whatever we have run. So if you don't have this jar file, basically you have to build your project. The way we build the project is right click, run as, Maven build, clean install. So this is the way we run the project. I believe everyone is aware of it by this time. Okay, now the build is done. I would like to build this project again for the Docker. I'd like to explain more on that. Yeah. So the first step is pulling the image. The next step is like mounting the volume. The next step is adding the jar file as an app.jar file and then exposing the ports. And the next point is to copy this entry point.sh to this file inside the content inside the Docker image that you are building. And then we are running this permission, right? Run chmod plus x. Basically, you are giving an executable permission to this docker-entry point.sh. If you don't give it, basically it will not be able to launch the script. Eventually, the application will not get launched. So yeah, so now we have the Docker image ready. The next step is to how to push this Docker image into the Docker Hub. So what is there is a command that comes handy with Docker to check the list of images that you have built in your machine. So the command is Docker images. If you give Docker image, I have done a lot of Docker work in my machine, so I have a lot of Docker images in my local. So if you take a look at here, this is the image that we had built in the previous tutorial. So now, how to push this image to the Docker Hub? So in order for this to happen, basically we need to have a Docker Hub account. So if we take a look at the GitHub repo, so I have given the Docker images command as part of the GitHub repo itself. It's under the docker-commands.md file. So click on this hub.docker.com. So in here, basically what you have to do is you have to go and then give Docker ID, email address, and password. It will, you'll be able to sign up and then have a Docker Hub account created. So I have a Docker Hub account already, so I'm gonna sign in. So the account name is delete the lip and then the password. So I have successfully logged in into my Docker account. So here you see that this account, my user ID is delete the lip. If you remember from the previous tutorial I mentioned, I'll explain you why I gave the image ID with the starting name as delete the lip. So basically what happens is once you have your Docker Hub account created, so basically you'll be able to push the images. So when you actually push it, basically it looks for the username. The username should be the first part of the final Docker image that you create, and then followed by the actual artifact. So that's what we did in the last tutorial. So here what I'm going to do is, in order to actually log in into the Docker Hub account, so basically what you have to do is you have to do a Docker login. So if you go to the GitHub repo with all the commands, there is a command called docker login. So type this one and then I'm gonna clear this. So docker login, that's the first step. So it'll ask you for the credentials, type the credentials. So now I am inside I have logged in into the Docker. The next step is to push this Docker image into the Docker Hub repo. So the way to do it is Docker images, and there is a handy command docker push, and then give this command. So docker push delete the lip, that is a Docker image with the starting first few characters of the Docker image followed by the actual artifact ID. So now if you take a look at it, basically it is trying to push the image into the Docker Hub repo. So once it is successfully pushed, basically we can go to the Docker Hub website and then check whether this image is uploaded into the Docker Hub or not. So normally it takes some time because it is image with 23 MB. So it is trying to push that to the Docker Hub. We're pretty close. I believe it is in the last step. So now the image is successfully pushed into the Docker Hub. Let's go and take a look at it. So in here, if you go to Docker Hub, just refresh. You see here, right? This is the one which we actually pushed just now. So the lib slash docker learn boot Kafka manual offset docker. So this is an image which we created in our local. Right now that image is available in the Docker Hub. Basically, if you want this image, basically you can do a git pull and then git pull, you do the same thing. Now I have the image already, but still, just for the purposes of showing it, do a git pull. Git pull, it will actually give you that there are some issues going on with my credentials. So basically, yeah, when you do a git not git pull, sorry, I was totally wrong. Docker pull. Now it will pull the, since I have the image already in my local, so I did not make any changes to my local image. Or you might need these Docker, you might need to have the knowledge about these Docker commands if you want to work on Docker. So I have all those Docker commands pushed into the GitHub repo. Let's go through that one by one. So we are done with this part, meaning building the Docker image. We are done with that in the previous tutorial. Next thing is Docker images. I believe we have covered this one also, but still I would like to run it and then show as part of this tutorial. So the first one is Docker images. So it lists you what are all the images that you had built in your machine. This is the one which we had built as the latest one. So I'm gonna clear this. So the next command is how to run the Docker image. So now we have built the Docker image. How can you run the Docker image? So there is a Docker run command for that. So here I'm giving the option as -it, meaning that is interactive mode. So basically all the as soon as you launch this Docker image, all the logs will be printed and then it will be displayed in front of you. Let me show that by running that command. So here, so ours is a Spring Boot app, right? That's what we developed in our previous tutorials. So if you take a look at it, now we have launched that Spring Boot app, and then if you take a look at it, it is an interactive mode, meaning it will wait. I mean, the thread will be open. Basically, this will be the console when you want to do any operations on this application. Basically, all those logs and everything will be written in this console itself. There is another option called -d that is like run the container in the background. So if you want, we can explore that option too. I'm going to kill this process. So if you take a look at it, there is another command called docker ps-a. So basically what it does is it basically checks what are all the containers that got created. So here, let me do a clear and then run a docker ps-a. So this is a container which we created as part of the docker run command, and right now the status is exited, meaning we killed that docker container, right? That's why it is in the status of exited. So how do you delete this container? How do you remove a container from the Docker repository? Meaning there is a way you can do that. So the way you can remove the container is by running docker rm and then give the container ID. This will delete the container. But before I do that, I would like to explore one more. So here we have launched it in an interactive mode, right? I would like to run this whole process in the background. There is a way we can do that. The way is docker run -d. If you give d, it is going to instruct the docker to run this container in the background. So, but there is an issue. The container name /boot Kafka is already in use. So if you take a look at it, if you try to launch multiple containers with the same name, Docker will not let you run it that way. The reason being you cannot have multiple containers with the same name. So now what I'll do is I will go ahead and remove this docker rm, and then this is a container ID. The way I can remove a container is by running the docker rm command. So with this, so if I do a docker ps-a, there are no containers running. So use the docker rm command if you want to remove the container. Now what I'll do is I'll try to run the docker image with the -d option, meaning launch this container and run that container in the background. So now it created the container, but so if you remember from the previous section, meaning when we ran it with -it option, the whole thread, meaning all the logs were displayed in front of you, and it was waiting for any messages, or it was waiting to log the logs from the application, and then the thread was open, right? meaning you had to close it if you want to launch or run any commands in the same terminal. So there is this advantage. If you run it with -d, basically you instruct the Docker to run that image, to run that container behind the scenes. So here, if I do a docker ps-a, yep, so here this container, it got created and it is up and running. If you take a look at the status, it is up 36 seconds. So you see all these ports, right? 8000, 8443, 8080. So if you remember from the docker entry point.sh file, this is where we are actually exposing the ports. Oh, not here. So we are exposing the ports in the Docker file. So this is where we are exposing the ports, and you might be wondering what are these environmental variables that we are passing as part of the so here we pass environment. So the docker run command, here we are passing the environment, here we are passing the Kafka broker, right? You might be wondering what are those values and where is that used. So if you take a look at that docker entry point.sh file, so here we will use that to append it to the java-jar launch command. So here we set that profile -d spring.profiles.active to a stage, meaning I believe that is a value that we are passing. So in the docker run command, we are passing the environment value as stage and the Kafka broker value as localhost 1992. Yep, that's what here the -d kafka.broker will be 1992. If you take a look at that application.yaml file, so let's take a look at the application.yaml file. So basically you are overriding this value. You're overriding this value by passing value from the docker run command. I will explain you the reason why we are overriding it in a moment, but here the reason why we are passing those values is to override those default values and consider these values as the latest value. Do we have any other commands? Do we need any other commands? So if you want to remove image, for example, I want to remove this image altogether. Docker images. So docker RMI, I want to remove the image. So in that case, I will do docker RMI and then enter. Unable to, because it is used in our running container, right? Let us stop that container. Docker ps-a docker stop. So this is a stop command to stop the running container. So if you want to stop, then you have to run this command. Okay, now do a rm. So you cannot remove an running container. So basically it needs to be in stop mode if you want to remove the container from it. So now we have removed the container. There are no containers. Now we will try to remove that from the docker RMI. We will try to remove this image from the docker machine, from in our local machine. Now if you take a look at it, it would have removed that image, whatever that got created. There is no image with that name. It is really hard to connect to the local host from Docker containers. So we will have our Kafka broker and Zookeeper run inside a Docker container in this tutorial. We will talk to the Kafka broker and Zookeeper running inside the Docker using the Dockerized Spring Boot app that we developed as part of the previous tutorial. So I'm using an advanced Mac book. So if you're using, if you have installed Docker Toolbox for Mac or Docker Toolbox for Windows, then you must be using something like Docker Toolbox, Docker Quick Start Terminal. So ideally what you should be using is we should be using Docker Quick Start Terminal. This is the terminal that you should use. So but here I'm using iTerm since mine is upgraded machine. So I have Docker for Mac running in my machine. So in here, what we are going to do is there is a handy command which is docker ps-a. So it just gives you the list of Docker images that are running in your machine. Right now, if you take a look at it, there are no Docker images that are running in my machine. So what I'm going to do is I'm going to run some of the Kafka related Docker images. So one is a Zookeeper image and other one is a Kafka broker image. So I don't have those image in my local. So what I'm going to do is I have to pull that from the Docker Hub. Some of our friends who have created those Docker images for Zookeeper and Kafka broker and then published into the Docker Hub. So we are going to pull those images into our machine and then we are going to run those images in our machine. I have listed down the steps in this Kafka-docker-commands repo, meaning this MD file is available in the Teach Apache Kafka repo, the repo which I have been using throughout this tutorial. So run this command first. So I'm gonna go into this folder. So I have run it in my local already, just for the sake of checking it, how it is working and then how it will benefit us. So I'm gonna run this command. Git clone. Basically, this will we are cloning a GitHub repo. So it's cloning it. Now the clone part is done. So let us do ls. So there is a folder called Docker Kafka that got created after I did the clone. I'm gonna go inside that folder. So there is a Docker file. As you remember from the previous tutorial, a Docker file is always needed if you're going to build a Docker image or if you're going to pull a Docker image. I mean, for pulling the Docker image, you don't need it. So let's take a look at what does this Docker file looks like. So if you take a look at the Docker file, basically what it explains is it pulled this Java 8 from here and then create a bunch of directories, and then it is doing Kafka. It is creating the Kafka commands, and then it is running the Zookeeper commands and stuffs like that. So if you take a look at it, Kafka release archive, it is downloading the Kafka distribution from the Kafka website, meaning there is a US Apache website, and it does a bunch of steps. Let's get into the bottom of it and then run those images. The first step is docker run. So here the docker run command is a command which you use basically to run the Docker image. So we have not seen this command yet. So docker ps command is basically to list the list of Docker image that is running in your machine. Docker run command is to run the Docker image. So if you take a look at docker ps-a, there are no containers that are running in your machine. So the first step is we are going to run the Zookeeper Docker image. So basically it is going to go into this Docker Hub account and then pull this Zookeeper Docker image in your machine and then run that image in your local. So I have given the option as -d. Basically it is running the image in the background. If I do a docker ps-a, you see here this Zookeeper, there is an instance that is running. Previously there was no instance that was running. Now here we have a Docker image running, and this is the Zookeeper. So now we have a Zookeeper running inside the Docker image. Next step is to run the Kafka broker. So here, if you take a look at it, here we have given the name. So for each and every run command, you have to give a name. So if you take a look at here, we have given the name as Zookeeper. Here we have given the name as Kafka. That is the names which are referenced and displayed when you do a docker ps-a. So here we are linking the Zookeeper instance with this particular Docker instance, and then it is pulling the Kafka broker Docker image from the CHES. So basically, if you do a docker ps-a, now we have two images running. One is the Zookeeper instance and another one is a Kafka instance. So now we have Kafka broker and Kafka Zookeeper running in your machine. Basically it is running inside the Docker image. So now we have two containers. One container is Kafka and another container is Zookeeper. Now we are going to inspect what is the port and what is the IP. Basically, what is the IP address of this Zookeeper instance? So you pass docker inspect command. Basically, you do a network settings.ip address, and then you pass the name of the container. Basically, it will tell you what is the IP address that this particular docker image is running. So now you have 172.17.0.2. Let's see what is the IP address for the Kafka. So you just have to follow the steps, whatever that is given in this README. So Kafka address is 172.17.0.3. And the next thing is we are going to set two environmental variables. The first one is zookeeper. So if I do a echo $IP, it will give you the IP address of that particular zookeeper. So now we have zookeeper IP holds the IP address of the zookeeper instance. Now the next step is now we will do a echo of Kafka IP. So now the Kafka IP variable holds the IP address. Now what we are going to do is to check this, okay, whether this zookeeper and the Kafka broker is able to communicate to each other. Here we will run this command. So if you take a look at the command, we are doing a run, and then in our repo there is a file called it takes a file called Kafka topic.sh, and then it's going to create a topic, and then the replication factor is given as 1 and the partition value is 1, and then we are passing the zookeeper IP. So if you remember from our previous tutorials where we had zookeeper and broker running on our local machine, we normally pass the zookeeper IP, I mean local, as localhost colon 2181, because the reason why we have passed it as localhost was it was running in your local machine. Right now we are trying to connect to an instance that is running in a running in a Docker image, meaning running inside a different container. Now this zookeeper container and the Kafka container, the way to connect both of them is using this IP address. Now we have this set in our environment. Just run this command. Basically it will tell you it has created a topic called my topic. So now if you take a look at it, it created the topic called my topic. The way how it created is, so here you have run this Kafka topic.sh file. If you remember, we normally use /Kafka topic.sh file and give this create topic command, and it works the same way. Here it is trying to talk to that actual running instance, and then it executes this command. But if you take a look at it, for the zookeeper attribute, it is passing that zookeeper IP value which we had set it here. So this is how the wiring between the two Docker images, meaning two containers, happens. So the Kafka container is the one which actually creates a topic, but it requires that zookeeper instance IP address. The way that wiring happening here is via this zk underscore IP value that we are passing here. So now we have the Kafka and zookeeper running inside the containers, and they are able to communicate each other, and we have successfully created the topic. Now the next part is we are going to have our Dockerized Spring Boot app talk to these topics and publish the message and consume the message using the Dockerized Spring Boot app. The workflow starts from connecting to the Dockerized Spring Boot app and publish the messages from the browser, and the consumer will pick up the messages and just print it in the console. And the consumer is going to connect to the Kafka broker that is running as a separate container. So we will be using the same Spring Boot application that was demoed in the previous tutorial. So please use Quick Start Terminal for any kind of Docker related use activities if you are using Docker Toolbox. So let's start let's start running the containers one by one. So I'm going to bring the zookeeper container up. So before I do that, I want to make sure there are no other process or no other container that are related to Zookeeper, Broker, and that Spring Boot app that we develop is up and running. So no container is up and running. So the first thing is to bring the Zookeeper up. Now let's do the docker ps-a. So if you take a look at it, Zookeeper is up and running. The next step is to bring the Kafka broker up and running. Nice. And the broker is up and running. Let's do this. Okay, now we have both Zookeeper and the broker up and running. Now what I'm going to do is I'm going to set these variables. So we are setting the environmental variables zk underscore ip and kafka underscore ip. Let's do a echo and then see. Okay, it's 3. And then let's create a topic called my topic. That is a topic which the Spring Boot app, the Docker Spring Boot app, is going to try to connect and talk to. So we have created the topic. Now from the Kafka end, everything is set and up and running. Let's bring the Docker Spring Boot app up and running. So the command that we are going to use, we are not going to use this command. The command that we are going to use it at the bottom. So docker run will give a name, docker boot, and then we are passing that this is a broker address. So what is a broker address? The broker address is 172.17.0.3, and then we pass the port as 1992. I think that's the port that we are using. Let us do this. Do we have? Okay, we don't have the image, right? So let's build the image first. I believe somehow we missed it. I think I deleted it as part of one of the previous tutorial, I believe. I'm not going to make any changes over there. So now it's building the Docker image. So the Docker image is successfully built. So if you take a look at it, the name, whatever that is available here, is not the final name. So basically we need to add here this. So in the place after the offset, I believe the image has an hyphen docker. Okay, so now the Spring Boot app is up and running. Okay, and if you take a look at it, it is connected to the topic, my topic, that is created as part of the another Docker container, and then it is assigned to the partition. It has only one partition. Now this consumer is listening to the partition my topic -0. I'm going to do another instance of this. Okay, so now we have the consumer up and ready. Let's publish the messages from the browser. So if you remember from the previous tutorials, the Spring Boot app, basically it has a producer in it. The producer receives a message from the browser, and the browser, as soon as we push the message from the browser, that message gets posted into the topic, and this consumer will pick up that message and just displace it in the console, meaning displace it in the Spring Boot app console. Okay, now let's go to the browser. So this is a URL that you need to hit. So now it returned stage Spring Boot properties. Why did it return stage Spring Boot or properties? So if you take a look at it, this consumer is able to pick up the message that got posted into the Dockerized Kafka broker, and this consumer pull the message from there. So why is it displaying stage? So for that, in order to get the answer for that, so basically here we are passing the environment as stage, And if you take a look at our application.yaml file has, if you pass this profile as stage, it is going to print this value, meaning hello from stage Spring Boot properties. Now you have seen the complete workflow, right? So you have published the message from the browser, and the producer, which is part of the Spring Boot app, published the message into the Kafka topic that is running in a totally different container, and totally different Docker container. And then the consumer, which is part of the same Spring Boot app, pull the message from the Kafka broker, which is running in the same container as which is running as a separate container. So here we have the whole workflow working, meaning we have Dockerized the whole application. We have Dockerized producer and consumer, and Dockerized Kafka broker, and Dockerized Zookeeper. You might be wondering, here I have given the URL as localhost. How is it able to connect? Most of the cases, it will not work right away. So basically, you have to do some setting in your end. So I have given this URL, meaning if you run into any issues, for example, if you are getting page not displayed or something like that, then I highly recommend you to go to this browser, meaning this URL, and then you need to have this setting. So when you install the Docker toolbox for Windows or Mac or Linux or any other machine, you will be getting a VirtualBox. So basically go to VirtualBox, and then go to settings, and then go to advanced. No, not here, go to network, and then go to advanced. I believe this is not the correct one. Okay, so go here, and then click advanced. I think the instructions are provided clearly in the console. I'm just go to network settings, go to network, advanced, and you have to basically, there will be I don't know if this is a different version of Mac. I think I've changed a few things here. This will be NAT basically. Yeah, now I got it. This will be NAT, and then click on the port forwarding, and you have to have this setup here, TCP host 127.0.0.1, and the guest port should be 8080. So you have to have this setup done in your end. If you don't make this change, your browser might not be able to talk to the Docker container actually, if you give localhost. Why Kafka security? The answer is really simple. If your organization or if the content is related to some sensitive data such as usernames or credit card numbers or user address, then these data needs to be secured at any cost. If you are using Kafka for transmitting or storing sensitive information, then we need to ensure there is proper security and integrity for the data stored in Kafka. That's one of the primary reasons Kafka introduced the security module. We will talk about SSL authentication and securing the Kafka topic using SSL in the upcoming modules. Kafka Broker is a module which will have all these configurations set up. So this will be the final output that needs to be set in the server.properties of the Kafka distribution. Let's discuss the attributes one by one. Listeners and advertised listeners. We know these attributes from our previous lectures, but we did not have SSL enabled. Let's take a look at the current setup, how it looks like. So if you take a look at the server.properties, we have plain text colon / / 1992 and plain text colon / / localhost colon 1992. But in order to enable the SSL, we need to add SSL in front of in the place of plain text. So that's one of the first change. The next one is security.inter.broker.protocol. It can hold any of these values, but here we are going to enable SSL. We'll be using SSL in the place of security.inter.broker.protocol. There are, SASL and ACL are the other authentication mechanisms, but we are not going to cover those as part of this tutorial. Next is ssl.client.auth. this can hold required or requested values. What is the difference between those? Required meaning the client authentication is required. Requested meaning the client authentication is requested, but the client can still connect without the certs. This setup is not preferable. And the next set of attributes are ssl.keystore.location, ssl.keystore.password, and the type. And next is a truststore.location, truststore.password, truststore.type, and key.password. Before we dig into all these attributes, I would like to explain what is the difference between a trust store and a key store. Trust store and key store are very much similar in terms of construct and structure, as both are managed by the keytool command. Key store, let's talk about key store. From the name, we can say that it is going to store something. Basically, it stores a certificate and a private key of that certificate. This is a server-side setup, and this file is required at the server level. Next, we'll talk about trust store. Trust store is again a store which is going to store some certificates. So trust store of a client stores all the certificates that the client should trust. This is required at the client end. Next, we'll talk about how the SSL functionality works. Anytime a client will connect to the server will present its certificate stored in the key store, and the client will verify that certificate by comparing with the certificate stored on its trust store. So basically, both these stores will have some certificates. When it connects, it validates those certificates, and once that validation is successful, then the connection will be succeeded. Let's have a hands-on on how to generate these key store files. If it doesn't make sense, meaning if you are not able to understand by looking at the slide, just by the following demo that I'm going to show you, you will be able to relate everything. Okay, I have a GitHub repo created with all the list of files that needs to be followed to generate the key store and trust store files. The first step is we are going to generate the key store file. Here we are using keytool command to generate the key store file. So I'm going to run this. So in here I'm passing a value called 365, meaning the certificate is valid for 365 days. And the file that I'm generating is server.keystore.jks file. Okay, now I'm going to open terminal. So I have a folder called SSL new. Let me copy the command that I just. Okay, I've pasted the command and it is asking me for a password. So what I'm going to do is I'm going to give a password called Kafka 123. Now I want to cancel this operation. I'm not sure whether I gave the correct password. So I'm going to paste this one again. So it is asking for a password. So basically what I'm going to do is I'm going to maintain all these values here. So the password that I'm going to use is Kafka123. So Kafka123. So I gave the first thing that will ask is what is your first name and last name. I'm going to give my first name and last name as Dilip Sundaraj. So I would highly recommend you guys to make a copy of whatever values that you are giving, because we are going to use these values in the next steps basically. So the first thing what I'm going to give is I'm going to give Dilip Sundaraj. That's my first name and last name. And what is the organization unit? I'm going to give the value as teach. So I don't want this value. I'm going to remove it. Teach. What is the name of your organization? I'm just going to give xyz.com. What is the name of the city? I'm just going to give some random value, city 1. And what is the state? It is XY. And what is the country code? AB. And it is asking whether is a CN, OU, operational unit, organization, city, state, and country are correct. I'm going to type yes. And it will ask for a password. So my recommendation is that I'm going to use the same password for all different types of activities. So I'm going to give Kafka123. It will ask me the password again. I'm going to give the password Kafka123 again. Now we have generated the server, the key store file, server.keystore.jks file. Let us do ls. You see here, this file got generated just now. So we have generated this file. Now what we will do is, the next step, we're going to generate the certificate, meaning the certificate authority. Here you see that we are using OpenSSL require REQ. This is a command that is required to generate the certificate authority. A certificate. What is the certificate authority in the first place? A certificate authority is responsible for signing the certificates. So we have generated the keystore file. What does a keystore file will have? The keystore file will have the certificate and the private key in it. Now we want some certificate authority to sign that particular certificate that is sitting inside the keystore file. For that, we need to generate a certificate authority. So that is a step which we are going to follow now. So here, if you do ls, you just have the server keystore.jks file. After this, it will ask for the password. Here also I'm going to give the same password, Kafka123. So it will ask for those details now. If you remember, we gave these details in our previous step. So I'm going to take the values from here. The country name, the first thing that it asks is country name. What is the country name that we gave? It's a 2-letter code. The country code what we gave was AB. State or province name. So what is the state value that we gave? That is XY. Locality, city. The city value we gave it as city 1. Organization name. What is the organization name that we gave? The name of the organization is xyz.com. What is the organization unit name? The unit name that we gave was teach. What is the common name? So you can give any name. I'm just going to give my name in the place of this. What is the email address? I'm going to give my email address. So now if you do a ls, you have this CA key and CS cert file that got generated. Let's see what is the next step. Now we have created the certificate authority. The next step is, here we are going to generate the trust store. So what we are going to do is, we have generated the key store. Next step is the trust store. The trust store is similar to key store. It is going to store a certificate and a key in it. Okay, what is the command for that? So here, I'm going to copy this command. We're going to, if you take a look at it, we are importing the CS cert that we generated just now, meaning using this command, we are going to create the server.truststore.jks file, and at the same time, we are going to sign that file using the certificate authority. So in here, if you take a look at it, we are importing this file ca-cert. That is a file which we just created. And then we are creating this server.truststore.jks file. I'm going to give the same password. So it will give you a bunch of text here. So this is the certificate that it generates. So in the place of trust this certificate, I'm going to give the value as yes. Now, if you do a ls, you can see that we created this trust store file. Earlier, this was not there. After we ran the third step, we got this file. Now we have the trust store file, and that trust store file is signed by the certificate authority. We have this key store file that we generated, but it is not signed yet. Let's sign this file. The first step is, we're running this command, and then I'm giving the same password. Okay, we do a ls. So we added this the cert-file file got created just now, and then we have to run the OpenSSL command. Now if we do a ls, so basically you have this cert signed file got created as part of the previous step. And now what we are going to do is, we are going to import the CS cert and cert signed into the keystore file. Same password, trust, yes. So it's signed. Awesome. So now we have all these setup done. Now we have generated trust store file and key store file, and we have signed both the files. The next is a set of changes that we need to do in the server properties file. I have made the changes already. Let me So in the place of plain text, we change it to SSL, and the broker protocol is SSL, and we are doing the required, meaning every time when the client tries to connect to this broker, it is gonna validate the certificates in the using the trust store file and the certificate in the trust store in the server store file. Here we need to give the key store location and then the key store password, and the key store type is JKS. Similar way for the trust store. And the next one is a key password. The password that we maintain throughout is Kafka123. How to connect to SSL secured broker using console producer and consumer. In our previous tutorial, we have completed the setup for the Kafka broker. We will take a look at the setup required for consumer and broker. I have the Zookeeper and broker up and running with a secured configuration setup. Now, for the purposes of this tutorial, I have created a topic called demo topic-SSL against a secured broker. Let's take a look at the configuration of that. So if you take a look at this topic is pretty simple. It has one partition and one replica, and the topic name is demo-topic-SSL. What I'm going to do is I'm going to use the command that we have used in the previous tutorials and then check how the consumer is going to behave. I'm going to launch the Kafka consumer, and I'm going to use the regular command that we used in our previous tutorials. So the command that we have used to launch a consumer is this. So I've copied that. Okay, I'm going to paste it here. I pasted this. So in the place of my first topic, I'm going to give demo-topic-SSL. Let me check whether I can expand this so that it will be easy to understand what is happening behind the scenes. Okay, now I have it set up. I'm going to launch the command. So you see there are a bunch of issues. I see a bunch of exceptions that got generated after we launched that command. Let's see what are those exceptions. So it says endpoint with security protocol plain text not found for broker. As you remember from the previous tutorial, what we did was we actually changed the configurations, right? So in the server.properties, we changed this plain text to SSL. So it is complaining it is not able to find plain text. The reason being we have SSL setup and it is looking for some other additional parameters in the Kafka console consumer in addition to the regular Kafka consumer launch command. So what is the console consumer command that we need to use in order to pass these client trust store certificates and all those stuff? So let's take a look at that. So the launch command for Kafka console consumer with SSL enabled properties are Kafka console consumer.sh, and then you pass the bootstrap server, and then you pass the topic, and then here you pass something called client-ssl.properties. So what this file is going to hold is, so I have this file also present in this GitHub repo. I'll be sharing this as part of this tutorial. So if you take a look at it, we pass all these properties as part of that. In the client.ssl properties, we'll be passing the protocol and the trust store location and the trust store password and the key store location and key store password, and then you pass the key password. So all these values are present in the Kafka broker server.properties file also. Now what we do is we will just copy this command and try to launch it. So yep, I have the command here. I'm going to copy it. I'm going to launch it now. So I'm going to clear the console. paste. So now if you take a look at here, in the place of test, I'm going to give demo-topic-ssl. Okay, now we have this value set. See, the console, it actually made the connection and it did not throw any exception. The reason being, the trust store which actually holds the certificate and the trust store which is actually available in the config in the server properties file, basically the validation is successful. Right now it is connected to the Kafka broker. Now what I'm going to do is I'm going to launch the producer. So similar way in the producer also, you have to pass the so let me go clear. Okay, I'm right now in the bin folder of the Kafka distribution. I'm going to copy this command. Similar to consumer config in the Kafka console consumer.sh file, there is something called producer config. We pass the same client.ssl properties. And then what I'm going to do is I'm going to change the topic to demo type topic-ssl. So if you don't pass this SSL properties, the producer will not be able to push any message to the secure topic. So here we are passing the client-ssl properties, which has a required setup to connect to the secure topic. Okay, I'm going to launch this command. Okay, broker right now is connected to the producer right now is connected to the broker. I'm going to publish some messages. You see here, as soon as I posted the message, consumer is able to pick it up and then read the messages from it. Hello from secure broker. See, it is able to read the message from the Kafka broker. So right now, both the Kafka console consumer and Kafka console producer are connecting to the secure broker, and then they're able to publish the messages successfully. But you need to pass this producer config and consumer config as part of the shell scripts that we are using to launch the console producer and console consumer. How to implement SSL in Kafka producer using Java. Let's get to the coding. Okay, here what I'm going to do is I'm going to create a class. The class name is producer Kafka with SSL. Producer Kafka with SSL. Finish. So what I'm going to do is I have the code already available in the GitHub repo. I'm just going to copy the code and then I'll explain you the code line by line. So here, if you take a look at it, it is available inside the package called producer, and the class name is producer Kafka SSL. So I copied that. Then I pasted this. Let's resolve the compilation issues. So I'm going to import this class. So now we have resolved all the compilation issues. So if you take a look at here, in comparison to the previous tutorials, here we have added all these properties. And if you remember from the previous tutorial, we have this client-ssl.property file with all these attributes. It's a similar attributes we have set it up in here. What I'm going to do is here in the place of path, I'm going to give the path where I have my trust store, and then the path where I have my key store. So basically the protocol is SSL, and the trust store location where you have the trust store.jks file and the password for that. And the similar way here you have the password key store location where you have the key store.jks file, and the key store password, which is a password. Ideally, the scenario is you should never hard code the password in the source code file. It might be an environmental variable, or you might store this in some kind of data store, or you might have it if you're running it in a Kubernetes cluster. Basically, you can create secrets and save these secrets against those. So if you take a look at here, what we are going to do is we are going to iterate two times, three times, and then we're going to publish two messages only. And if you take a look at here, the topic which we have given here is my SSL topic, but for the purposes of this tutorial, we have created a topic called demo-topic-SSL. So I have the Kafka console consumer up and running with all the SSL properties which are passed as part of this console script. So I'm going to run this producer and then see whether it is able to connect to the secure broker and then publish the message, and whether this consumer is able to pull the message whatever the producer published from. Okay. So in here, if you take a look at it, the producer connected to the secured broker using all the configurations we provided as part of the Kafka producer config, and then it made the connection and published the messages into it. Here, if you take a look at it, as soon as the messages got published to the secured broker and the topic which is inside the secured broker, it is able to pull the messages from that topic. If you take a look at the topic name in the console consumer, it's demo-topic-SSL. How to implement SSL in Kafka consumer using Java. Let's get to the coding part of it. So here, what I'm going to do is in the consumer package, I'm going to create a class called consumer Kafka with SSL. The class name is consumer Kafka with SSL. And I have the code already available in my GitHub repo. I'll just going to copy and paste it here, and then I'll explain you the code line by line. So in here, okay, let's resolve these compilation issues. Okay, import the other list, import the consumer records package. What happened here? Okay, import the consumer record. Okay, now we have imported everything. So if you take a look at here, similar to console producer, we have the console consumer settings. The settings are almost similar compared to the Kafka producer. Here you have to provide the SSL, and then we have to provide the path here where you have your trust store and key store in your local workspace or on your local machine. So I'm going to copy those values actually. So it's there in my client .ssl.properties. I'm just copying this path, and I'm going to copy it in the place of path. Nothing much to explain here. It is the same as the previous configuration. So in here, in the place of topic, we should give demo-topic-SSL. Okay, so that is the topic we're going to connect. There are no changes to this, and then it's going to poll every 100,000 milliseconds. And okay, this consumer is gonna read these from the secure Kafka broker. So all the configuration setup for connecting to the secure broker is set. Let's launch this class. Rest all the code, or it's pretty straightforward. If you had gone through the previous tutorial, you might be knowing this by now. I'll run it. Okay. So now I have the producer up and running here in the local console producer. What I'm going to do is I'm going to publish the message and then see whether this consumer is able to read those messages from the demo topic or not. Hello. See, now consumer, the producer pushed the message into the secured topic by passing all these client SSL.property values. And here we have all the SSL configuration set up in our Kafka consumer, and then it is successfully able to make the connection to the secured Kafka broker, and read the messages whatever the producer is publishing. Are you secure? So in here you see all the messages are read from the secured Kafka broker. Okay, with this we came to the end of the Kafka consumer, and thank you for watching.